It begins, as it always does, with silence. A cold, imperceptible stillness that stretches between stars, vast, unbroken, eternal. Out there, beyond the familiar rhythm of our sun and its retinue of planets, something moves. It is not born of this place. It does not belong to the clockwork of the solar system, nor to the quiet patterns that have lulled astronomers into a sense of cosmic order. It comes from elsewhere, a realm so far beyond imagination that even light, unbound, takes centuries to remember its path. In the beginning, there was no warning, no flare, no ripple of gravity. The solar system, ancient and self-contained, continued its indifferent spin. But then, through the darkness between Neptune's cold orbit and the Oort cloud's whispering edge, a traveler entered, silent, slender, and swift. It had no name yet, no story, no reason to exist. Yet its arrival would mark one of the most disquieting moments in modern astronomy, the appearance of the third known interstellar object, now called 3I Atlas. From the perspective of deep time, it was nothing a mote among billions, but to human eyes, trained on the endless dark, its intrusion carried a strange gravity, not physical but psychological. For the first time since Oumuamua and Borisov, another visitor had come to us, uninvited, slipping through the solar system's gate like a ghost caught wandering from another world. What makes such an object terrifying is not its size, nor its speed, nor even its path. It is what it represents. A message, written in the language of motion, whispering of other stars, other systems, and the possibility that the universe is far more interconnected or far more haunted than we dare to believe. 3I Atlas was first nothing but a flicker of reflected light, a faint, inconsistent speck in the data feeds from Earth-based telescopes. It blinked against the static of the night sky like a heart skipping a beat. Its brightness shifted with no pattern. Its orbit, when first calculated, appeared absurd. Objects from other stars were supposed to be rare, anomalies of cosmic drift. Yet here was another, arriving barely years after the last. Something in the rhythm of the universe had changed. In cinematic silence, the narrative of humanity's encounter with the interstellar unknown begins again. But unlike before, this time, the patterns were wrong. Oumuamua had been odd, elongated, tumbling, seemingly accelerated by invisible means. Borisov had been simpler, a cometary traveler obeying the laws of chemistry and light. But 3I Atlas was different. It was not simply strange, it was impossible. Astronomers stared at its path, a trajectory too steep, an inclination too deliberate. It entered the solar system like a thought intruding upon a dream, with no traceable source. Its velocity, when calculated, suggested it had been wandering the interstellar void for eons, perhaps, since before the sun itself had ignited. And yet, its direction told another story. It seemed to be coming from somewhere. The night sky offers no landmarks. Every direction is infinite, but to those who watch the heavens with precision instruments, every deviation, every asymmetry carries meaning. The arc of 3I Atlas hinted not at randomness, but intent, a path that sliced through the galactic plane as though charted, not chanced. Even Brian Cox, speaking with the serene cadence that only the cosmos can evoke, would later describe its arrival as a humbling reminder that the universe is not obliged to make sense to us. Behind the poetry, there was unease, because when things move without obeying celestial mechanics, when they appear from the black between stars and depart without explanation, science begins to tremble at its edges. For centuries, astronomy has been an act of quiet faith, that the universe is consistent, that mathematics can translate its mysteries, and that the unknown will yield to light. But 3I I Atlas did not yield. It defied the logic of orbits, the expectations of mass, and the comforting rhythm of prediction. Its very presence posed a silent question. How many more such travelers have passed unnoticed, invisible to our limited gaze? And if this is the third we have found in so few years, what are the odds that they are merely fragments of cosmic accident? Perhaps then, the universe is not so empty. Perhaps it is alive with motion, purposeful, deliberate, ancient. The first images of 3I Atlas were hauntingly unimpressive, a dot among dots, indistinguishable to anyone but those who knew how to read the sky. Yet beneath that simplicity lay the implication of immensity of distances beyond reckoning, of origins beyond comprehension. To see it was to glimpse the untamed sea beyond the shores of our solar system, to recognize that the cosmos does not end with the sun's faint gravity. In those first days, scientists celebrated the discovery, unaware of the darker questions it carried. They called it another interstellar object, another chance to study the relics of distant systems. But in the stillness of observatories, under the low hum of tracking computers, a quiet unease began to spread. Its motion was too erratic, its reflectivity too unstable, its shape inferred through light variation too complex. It did not act like a rock, it did not look like a comet, it behaved like something that wanted to hide. And as its faint glow crossed the line of Earth's orbit, humanity once again faced the ancient fear that the sky might be watching back. There are moments in science when discovery feels less like enlightenment and more like intrusion, as though we've stepped into a room we were never meant to enter. 3I Atlas was such a moment. It carried with it the whisper of otherness, of distances we are not ready to cross, of forces we do not yet comprehend. It was not a visitor, perhaps, but a reminder that the universe is not ours to understand. It is vast and cold and old beyond measure, and sometimes, from that abyss, something stirs and drifts close enough to remind us of our place. This is the story of that reminder, of the object called 3I Atlas, of the questions it brought, and the terror it left behind. It began with a whisper of light that should not have been there. In late 2024, the Atlas survey, the Asteroid Terrestrial Impact Last Alert System, was doing what it was designed to do, scanning the heavens for threats. Its twin telescopes, stationed in Hawaii, sweep the entire visible sky every night, searching for the subtle movements of near-Earth objects that might one day collide with our fragile world. But that night, the computers flagged something peculiar, not because it was heading toward Earth, but because it was moving too fast to belong here at all. A data anomaly, they thought. Another glitch, perhaps a miscalibrated pixel or a cosmic ray flash contaminating the image. But as they cross-checked the observation with later frames, the motion was undeniable. A faint, persistent smudge had shifted in ways that betrayed an object from deep space, one that was entering the solar system with impossible velocity. The astronomers at the Atlas Observatory had seen this story before. In 2017, they had watched the interstellar wanderer Oumuamua streak through the system like a ghostly spear. In 2019, Borisov had followed a more ordinary comet from a faraway Sunday. But this new arrival, detected from Haleakala's thin air and volcanic peak, seemed to repeat the pattern with unsettling precision. A third interstellar object, found just years after the last, defying every expectation of cosmic probability. They named it provisionally as C2024A3, Atlas, assuming it was a comet. Later, after its hyperbolic orbit was confirmed, it would earn the permanent designation 3I Atlas, the third interstellar object ever found, and the most troubling. The initial discovery was routine, a small brightening against the stellar background, moving faster than typical solar system bodies. yet its brightness curve, the measure of how its light fluctuates, betrayed something strange. It pulsed erratically, as if its surface were uneven, fragmented, tumbling. Some frames showed it brighter than expected, others almost gone, as if light were scattering from a shape too complex for a simple nucleus. Dr. John Tonry, part of the Atlas team, reportedly stared at the readings for hours. "It doesn't behave like a comet," he muttered, though at that early stage, no one wanted to speak such heresy aloud. Comets, after all, are familiar. They melt, they flare, they vanish. They are born of the sun's touch. But this came from another star, and its glow was wrong. Across the Pacific, other observatories took up the chase. The Pan-STARRS telescopes confirmed the detection. The European Southern Observatory began its own tracking sequences, and like the slow spread of unease, the data began to whisper the same message. This object was moving at a velocity that could not be captured, not even by the Sunday. Its inbound speed exceeded 26 kilometers per second relative to the solar barycenter, a speed that rendered it unbound. No orbit would hold it. It was passing through, destined to visit and vanish. But its trajectory, the trajectory was something else entirely. Instead of descending along the predictable lanes of the ecliptic plane, where planets and asteroids dance to gravity's ancient rhythm, 3I Atlas entered at an extreme inclination nearly perpendicular, slicing through the solar system's disk like a blade through fabric. It did not follow the pattern of planetary birth. It ignored the geometry of our sun's domain. It was alien in both origin and intent. When astronomers reconstructed its path backward through time, it pointed toward the outer spiral arm of the Milky Way, toward no particular star, but toward the cold hinterlands between systems. The distances were unimaginable, light years of emptiness, through which this single body had traveled unperturbed for millions, perhaps billions, of years. And yet, there was something disconcertingly specific about its arrival. Its perihelion, the point of closest approach to the Sun, was set to occur within a range that allowed human observation, statistically improbable, almost deliberate. Soon, the global community of astronomers began to coordinate. The Minor Planet Center issued circulars. Amateur astronomers joined the hunt. Every new observation refined the mystery. Its brightness rose and fell unpredictably. Its coma, the gaseous envelope expected from sublimating ice, appeared faint, asymmetrical, even inconsistent. Some nights, it shone like a living ember. Others, it faded to nothing. The Atlas team, disciplined by years of false alarms, logged their findings with clinical precision. Yet beneath the data, there was emotion, the quiet tension of those who sense something vast moving behind the veil of numbers. Brian Cox, when later asked about this period, would remark with characteristic restraint, "Astronomy has always been a conversation with the unknown, but sometimes the unknown answers back." In laboratories and lecture halls, the discovery of 3I Atlas stirred memories, the same shiver that followed Oumuamua's discovery 7 years before. The same disquieting thought, we have only just begun to look into the dark, and already it looks back. Yet even as headlines began to form, NASA's official statements were muted. An interstellar object, they said. An exciting opportunity for observation. But behind the caution, emails circulated, internal memos urging patience and silence. The data, they claimed, was preliminary. But those who knew the math could see the impossible curves forming. They saw the way the orbit bent as if drawn by invisible hands, the way the brightness changed with a rhythm that felt patterned. And, somewhere in the collective mind of science, a door began to open, one that would not close again. Because if 3I Atlas had truly come from another star, what else had traveled with it? What forces had sent it here? And how many times had this happened before, unseen, unmeasured, unnoticed? It was as though a message had been thrown across the ocean of space, drifting until some distant intelligence finally lifted it from the tide. Humanity had just picked up that message and found it written in a language we do not yet understand. The night it was discovered, the telescopes continued their sweep, the stars turned, the planets spun, but somewhere beyond the thin veil of our atmosphere, an ancient traveler crossed the void between suns, silent, steady, and watching. It was not merely a discovery. It was a reminder of how little control we have over what enters our sky. And as 3I Atlas continued its descent toward the sun, it carried with it the quiet, terrifying beauty of all things that come from the dark. Names are the first illusion of understanding. To name a thing is to cage it in language, to give it an address in the vast disorder of reality. Yet when the astronomers christened the third interstellar visitor 3I Atlas, the act felt hollow ceremonial, almost desperate. The name stood for Third Interstellar Object, and the suffix honored the telescope system that found it. But in truth, the object had no name. It had no history, no mythology, no place in our shared sky. It was not a comet, not an asteroid, not anything familiar. It was simply a stranger passing through. In the early weeks after its detection, the story of 3I Atlas spread quietly across scientific circles, whispered between observatories, shared in encrypted data packets, spoken of in cautious tones on conference calls between NASA, ESA, and independent researchers. They knew the discovery was important, but they also knew it was dangerous, because to accept another interstellar visitor so soon after the first two meant rewriting our understanding of the cosmic neighborhood itself. Oumuamua, in 2017, had already unsettled the world. Its strange shape, its non-gravitational acceleration, its eerie silence, it became a cultural and scientific obsession. Then came Borisov, the second, whose icy coma offered relief. Something ordinary, something explainable. But 3I Atlas did not bring comfort. It carried contradiction. Unlike Borisov, it did not behave like a comet. Unlike Oumuamua, it did not tumble with the chaotic spin of a shattered rock. It shimmered inconsistently bright one day, dull the next, as if light scattered off surfaces that were not natural. The Atlas team's designation made it official, but scientists around the world hesitated to categorize it. Was it a comet? An asteroid? A fragment of some interstellar debris field? Or was it something entirely new, an archetype for a class of objects yet unknown to cosmology? For the first time, the word interstellar no longer evoked poetic distance but immediate unease. To label something as interstellar is to admit it has crossed the gulfs between suns and therefore carries the chemistry, the history, the potential of other worlds. It is the scientific equivalent of a message in a bottle, thrown into the cosmic sea, washing up on our shore. And yet, unlike a bottle, 3I Atlas showed no signs of weathering. Its reflective surface hinted at fresh material, unaged by eons of cosmic radiation. That detail disturbed many. How could something wandering through interstellar space remain so pristine? Soon, laboratories began to analyze the light spectrum pouring from the object. Teams from Chile, Hawaii, Spain, and Arizona pointed their instruments skyward, dissecting the photons that had bounced off its skin. The results were disquieting. An unfamiliar mixture of carbon chains and silicate bands, not inconsistent with organic compounds, yet arranged in ways not observed in known comets. For astronomers, this was like discovering a fossil with bones that did not fit any species. The name Atlas now echoed through headlines, carrying both pride and anxiety. The world's media framed it as another cosmic curiosity, a comet from another system, perhaps beautiful, perhaps harmless. But beneath the surface of those placid press releases, scientists were writing very different memos. They had noticed the anomalies, the faint, erratic changes in reflectivity, the unaccountable acceleration patterns, the inconsistency in its apparent mass. Some even questioned whether the object was tumbling at all or if its rotation was being modulated. Still, the official line remained cautious. The astronomical community has long practiced a kind of sacred restraint to speak only when data is certain, but certainty was impossible here. The more they measured, the less sense the object made. And so the naming of 3I Atlas became symbolic of something larger: humanity's need to define what it does not understand, to bring order to the unknown through taxonomy. The name became a placeholder for confusion. Yet even as that confusion deepened, another truth began to take shape. 3I Atlas was not behaving as an isolated body should. Its passage through the solar system seemed orchestrated by an invisible hand, not in the sense of conscious control, but as if its trajectory had been fine-tuned by the laws of physics themselves, optimized for observation. It would come close enough to be studied, but not close enough to risk collision. Its perihelion distance, just inside Venus's orbit, offered a near-perfect vantage point for telescopes. Its approach angle avoided the blinding glare of the sun, allowing prolonged tracking. To the seasoned minds of celestial mechanics, this was unnerving. Too many coincidences stacked together. Brian Cox, in an interview months later, described it with unsettling simplicity. It's as though the universe wanted us to notice. Of course, coincidence does not imply intention, but humans are pattern-seeking creatures, and in the quiet corridors of astrophysics departments, that tendency became a source of sleepless nights. Some whispered that 3I Atlas was the harbinger of something more, a pattern emerging from the noise of the cosmos. For millennia, humans have looked to the heavens and seen meaning in the movement of stars, but modern science, in its humility, stripped the sky of omen and myth. And yet here, amid the cold data streams of 21st century astronomy, myth began to whisper again. The interstellar traveler had returned, not once, but thrice. And perhaps it would not be the last. To name is to tame, they say. But in this case, the name 3I Atlas tamed nothing. It was a fragile shell placed around a mystery that refused containment. The numbers and letters sterile, technical, hid a quiet truth that would soon echo across the scientific world. We are being visited, not by life, not by message, but by reminders, fragments of a wider reality that refuses to remain hidden. And as telescopes across Earth continued to capture its fading light, one question began to echo, soft but persistent, beneath the hum of machines. If this is the third, where is the fourth? And what happens when we finally meet one that isn't passing through but stopping? The answer, for now, remains beyond the reach of human language. All we have is a name and a silence that grows heavier with every passing night. In the long corridors of data, it began as a whisper, just a flicker, just a deviation too small for the untrained eye to see. The light curve of 3I Atlas, plotted by tired scientists on glowing screens, began to pulse in irregular rhythms. It was not the graceful consistency of a tumbling rock, nor the predictable flare of a comet venting gas. It was uneven, erratic, alive in its own strange tempo, like the pulse of a heart, but one that beat to no rhythm we could understand. The discovery came quietly, buried among lines of numerical code. Graduate students and astronomers from observatories across the world compared notes, trying to make sense of the light's strange oscillations. Some suspected instrumental interference, others blamed atmospheric distortion, But when data from multiple telescopes, separated by oceans and hemispheres, revealed the same pattern, denial began to crumble. Something about 3I Atlas was flickering. Something was wrong. At first, the team at the University of Hawaii thought it might be rotation, an irregular spin causing sunlight to scatter differently as the object tumbled through space. But when they modeled the spin dynamics, they found that no shape, no rotation period, and no orientation could reproduce the observed light fluctuations. The brightness would spike too sharply, then flatten for hours, then vanish into darkness as if the object itself were absorbing light instead of reflecting it. This wasn't chaos, it was inconsistency, a kind that suggested structure. More telescopes joined the hunt. The Lowell Observatory in Arizona, the European Space Agency's Gaia probe, and Japan's Subaru telescope began monitoring the object as it slipped inward toward the Sunday. Every dataset confirmed the same thing. The light curve could not be stabilized. The algorithms that normally reconstructed an object's size and spin simply broke. They returned conflicting results, sometimes suggesting an object a few hundred meters long, other times several kilometers wide. Its inferred density, too, changed with each run. A comet cannot do that. An asteroid cannot do that. And so the whispers began. In the dim red glow of control rooms, researchers spoke quietly of surface activity, of shifting albedo, of shadows that moved when they should not have. The official reports remained clinical phrases like non-periodic photometric variation and complex rotation parameters filled the logs, but beneath the surface there was unease. For 3I Atlas seemed to be telling a story through light, a story we couldn't read. The object's reflections grew brighter as it approached the sun, but not smoothly. Instead of a steady curve of illumination, the brightness spiked in discrete jumps, as though it were reflecting light from facets mirror-like surfaces, turning deliberately toward the star, then away again. NASA's Jet Propulsion Laboratory built a composite from all available readings, feeding them into the Deep Space Network's predictive model. The result was strange. The shape reconstruction algorithm, a mathematical tool that builds 3D models from light patterns, returned an impossible form. It wasn't a cigar or a pancake like Oumuamua. It wasn't a sphere. It was irregular, segmented, almost modular. One analyst described it as a cluster of fragments moving in unison. Another called it a fractured sail. Theories multiplied like shadows. Some suggested that 380 LAS was a disintegrating comet whose icy core had cracked under thermal stress. Others proposed that its outer layers were made of exotic materials that responded differently to sunlight. But a few quieter voices in the background, voices who remembered the Oumuamua debates, wondered if it was something else entirely. The flickers became the heart of the mystery. Because they didn't just happen at random, they followed faint patterns, repeating over intervals too complex for natural tumbling, but too regular for chaos. Machine learning systems at Caltech tried to decode the signals, searching for periodicity. For hours, the computers stared into the digital noise until faint harmonics began to appear. It wasn't Morse code, nor radio transmission. It wasn't any kind of signal we could understand. But the brightness variations occurred in numerical ratios, mathematical relationships like 3, 5, 8, the Fibonacci intervals found in organic growth, spiral galaxies, and DNA helices. Coincidence, said some. Pattern-seeking paranoia, said others. But for those who had dedicated their lives to the sky, it was something else. It was the first tremor of awe, the ancient human fear that the void might not be empty after all. As data poured in from the Vera Rubin Observatory, the object's color spectrum added another layer to the unease. Unlike known comets, 380 AALAS showed no consistent signature of cyanide, water, ice, or carbon dioxide, the gases that define cometary tails. Instead, its reflected light carried spectral lines associated with magnesium silicates and carbon nanostructures, materials that implied not ice but metal. And yet, the object released dust fine, dark grains that scattered sunlight faintly behind it. The dust was not made of typical cosmic silicates. It contained traces of nickel and titanium, elements that hint at formation in extreme stellar environments, near supernova remnants or in planetary foundries far older than Earth. It was as if this thing had been forged in a furnace and left to wander. Still, NASA's official position remained grounded. Natural explanations are preferred. Their internal memo stated, surface irregularity, fragmentation, or non-homogeneous composition likely contributors. Yet even within those carefully chosen words was a subtext of alarm, because the models still didn't fit. The object's trajectory, too, was subtly changing. Observers noticed a slight deviation from the expected gravitational curve, an acceleration that could not be explained by solar radiation alone. It was the same anomaly that haunted Oumuamua's path years before, a ghostly push from nowhere. In a late-night interview, Brian Cox described this moment beautifully and chillingly. When light itself begins to behave as if it's following an intention, we are forced to look at the possibility that physics is not a closed book, that perhaps the laws we know are only the first chapter. And so the story of 3I Atlas deepened not through the roar of discovery, but through the whispers in its data, through the irregular heartbeat of reflected sunlight, the uneven breath of dust, the trembling graphs that no one could explain. In those flickers, humanity glimpsed the edge of comprehension, a line between what we can measure and what we are meant to understand. And somewhere beyond that line, hidden in the tumbling glare of a stranger from another star, something ancient continued its silent drift through the light. It was only later, when the data from multiple observatories had been layered together, pixel by pixel, wavelength by wavelength, that the scientists began to understand what they were looking at. The reflections from 3I Atlas were not random, they were spectral signatures, the fingerprints of its surface composition. And these fingerprints told a story that no one expected, a story that suggested the object was not merely from another solar system, but from a place unlike any we've ever known. Each interstellar object that has ever wandered into our neighborhood carries with it a kind of cosmic accent, a chemical dialect born of its parent star, its primordial dust, and the radiation that shaped it. Comets from our system sing in familiar tones: water ice, carbon dioxide, ammonia, organic molecules, and silicates, the universal bricks of planetary chemistry. But the spectrum of 3I Atlas was a foreign language entirely. Infrared analysis revealed a mixture of volatiles inconsistent with any solar nebula chemistry. Hydrogen cyanide bands were muted, methane absorption peaks were shifted, and the ratios between magnesium, nickel, and iron in its trailing dust were skewed beyond what models of stellar formation could explain. Dr. Karen Meach, one of the foremost planetary astronomers involved in studying interstellar bodies, summarized the finding with quiet restraint. Its isotopic ratios suggest it formed in a region of space that cooled under conditions we do not observe anywhere near the Sunday, possibly under a different type of star altogether. A different type of star. That phrase lingered in the data logs like an echo. When the European Southern Observatory cross-referenced the readings with stellar population maps, the results were haunting. The materials were most consistent with formation near an aging red giant, the kind of dying star that sheds its outer layers in clouds of carbon and silicate dust. Such stars are nurseries for exotic compounds, but few of their fragments ever escape into interstellar space. Fewer still travel far enough to cross paths with other suns. And yet, 3I Atlas had done just that. It had travelled across the spiral arms of the galaxy, from a dying world into ours, carrying the ashes of a system long extinguished. Somewhere, perhaps 500 million years ago, a planet may have been shattered, its debris flung outward by a dying star's last breath. Some of those fragments, metallic, crystalline, ancient, were hurled into the abyss. Over eons, one of them wandered into the pull of our Sunday. But there was more to it than that. The ratios of certain isotopes, particularly deuterium to hydrogen, were not merely unusual, they were impossible. These ratios implied formation temperatures so low that no known stellar nursery could produce them, unless, of course, the object had not formed naturally at all. In a paper circulated quietly among theoretical physicists, one line stood out. Spectral inconsistencies may suggest non-stellar synthesis. The phrase was deliberately opaque, but to those who read between its lines, it hinted at something unspoken, that the materials could have been engineered. No one wanted to say the word. It was too early, too reckless. But behind closed doors, the idea simmered. Could 3I Atlas be a remnant not of nature, but of technology? The more they looked, the stranger it became. The composition of the dust trailing behind it contained traces of pure nickel, an element that, in such refined form, almost never occurs in nature without processing. Its presence implied exposure to temperatures high enough to vaporize rock and then to cool under vacuum conditions so extreme that only advanced metallurgy or the core of a dying star could replicate them. It was a paradox, evidence of extreme heat and deep cold, of both creation and decay. NASA's Goddard Center attempted to recreate its infrared spectrum using laboratory samples, mixing silicates, organics, and alloys under simulated interstellar conditions. None matched perfectly. Each attempt produced light that was either too red, too dim, or too reflective. The real 3I Atlas remained an outlier, a ghost of matter from an unknown chemistry. When the first composite 3D model was rendered a spectral reconstruction built from hundreds of observations, it showed something deeply unsettling. The surface was irregular, but not chaotic. There were repeating geometric ridges, lines that hinted at fracture or segmentation symmetry that nature rarely favors. An astrophysicist at JPL reportedly muttered, "It looks machined." The room fell silent. No one responded. They simply kept working, eyes fixed on the data, as if speaking the thought aloud might shatter the fragile peace between reason and wonder. The realization spread through the community in fragments, through whispered conference hallway conversations, encrypted emails, and private research logs. 3I Atlas might not be a simple piece of rock. It might be an artifact not functional, not alive, but a relic, a silent messenger from a civilization long gone, adrift for eons between the stars. If true, it would change everything. It would mean that humanity was not the first species to leave its mark upon the cosmos. It would mean that somewhere, sometime, another intelligence had reached beyond its world, and in doing so, left behind debris that outlived its creators. Brian Cox, reflecting on this possibility, spoke softly on a late-night BBC interview. The idea that we might be sifting through the ashes of alien engineering is both exhilarating and tragic. Exhilarating because it suggests we are not alone, tragic because it means they are gone. But even for those unwilling to embrace such speculation, the scientific puzzle remained terrifying on its own terms. Because even if 3I Atlas was purely natural, it still came from a region of space governed by laws of chemistry and heat that should not exist. It suggested that matter itself, the building blocks of planets, stars, and life, may behave differently across the galaxy. What we call universal physics might not be universal at all. And if that is true, if even the matter between stars carries secrets incompatible with our understanding, then every discovery becomes a confrontation with the limits of human comprehension. 3I Atlas did not simply arrive as a curiosity, it arrived as a warning that the universe is not obliged to obey our mathematics, that reality itself may hold variations as vast and mysterious as the stars that gave them birth. And for a brief moment, as astronomers gazed upon the spectral data glowing like ghostly fingerprints across their monitors, they realized something profound. Perhaps what frightened them most was not the possibility that 3I Atlas was alien, but that it was perfectly natural, that somewhere out there, in the cold furnaces of another cosmos, nature had built something that looks like intention. There are moments in science when mathematics itself falters, when the familiar equations begin to hum with unease, when Newton's gravity no longer draws the lines cleanly, when relativity offers no comfort, when the orbit itself begins to whisper of something wrong. The day the calculations for 3I Atlas came back broken was one such moment. The first to notice was a quiet astrophysicist working late at the Minor Planet Center. His simulation of 3I Atlas's trajectory refused to converge. Every gravitational model, Sun, Jupiter, the subtle tug of the galactic tide, produced a residual acceleration, a tiny push that should not exist. It was small, barely a few 10,000ths of a meter per second squared, but it was there, and it pointed away from the Sunday. Non-gravitational acceleration, the same ghost that haunted Oumuamua. For the uninitiated, this means the object was not simply coasting under the pull of gravity, it was being pushed. Normally, such behavior is caused by outgassing jets of vapor erupting from a comet's surface as it warms, like invisible thrusters nudging it along. But 3I Atlas showed no such jets, no plumes of dust, no cometary tail, no ultraviolet emission lines from evaporating ice. Its acceleration was invisible, silent, almost intentional. When the data reached NASA's Jet Propulsion Laboratory, the reaction was subdued but immediate. Analysts double-checked the astrometric measurements. They recalibrated for telescope error, solar wind pressure, and even thermal recoil, the gentle push caused by heat radiating unevenly from an object's surface. None of it could explain the anomaly. "What you're looking at," one orbital dynamicist said in a closed session, "is something that doesn't behave like a rock, a comet, or a fragment. It behaves like a sail." That word sail lingered in the air like a heresy. It recalled the old debates around Oumuamua, when some physicists, including Harvard's Avi Loeb, proposed that the first interstellar visitor might have been an artificial light sail, a fragment of alien technology propelled by starlight. The idea had been dismissed as speculation, but now, with 3I Atlas, the same pattern was emerging. The same eerie acceleration, the same refusal to conform. If Oumuamua was the whisper, 3I Atlas was the echo. The object's orbit carried it deep into the inner solar system, where solar radiation grows fierce. As it neared the Sun, the anomalous acceleration increased, exactly as one would expect for a light sail, a structure large and thin enough to be pushed by photons. Yet, the strength of the effect didn't match. It was too consistent, too clean, as if the object's surface were optimized for reflection. Still, NASA's public position remained conservative, outgassing from unknown volatiles. But even their internal memos grew hesitant. The cometary model failed. No gas emissions, no tail, no rotational torque, nothing that fit. In conference rooms lit by the blue glow of projected orbits, scientists stared at simulations that refused to obey. The elegant ellipses of celestial mechanics fractured into wild deviations. Every time they adjusted the parameters to make sense of the data, The universe seemed to push back, as though mocking the effort. One paper, circulated among the International Astronomical Union, put it plainly: the observed motion of 3I Atlas cannot be fully explained by gravitational and known non-gravitational forces. Additional modeling required. In the careful language of science, that is the equivalent of a scream. Theorists began to speculate. Could electromagnetic interaction with the solar wind explain it? Could dark matter density gradients exert subtle influence? Could there be unknown particles, relics of cosmic inflation, interacting with interstellar bodies in ways we had never measured before? And then came the stranger thought: perhaps this object was not resisting gravity, but obeying another. In Einstein's vision, spacetime is not a stage, but a fabric, curved, rippling, alive. Massive bodies bend it, and smaller bodies follow the curves. But what if 3I Atlas followed a curvature of spacetime that we cannot see, one written not by mass, but by something deeper? What if the object had structure that allowed it to sense, or exploit, these hidden gradients? Brian Cox spoke of it in a televised lecture, his voice low, reflective. Physics gives us the illusion of completeness. We think we understand gravity because our equations work. But when something moves against those equations, it's not the universe that's broken, it's our understanding of it. By this time, every major observatory was tracking the object. The European Space Agency's solar orbiter captured faint reflections as it passed perihelion. The readings confirmed the acceleration. It was real, predictable, yet unexplainable. The fear was not that 3I Atlas violated physics. It was that it expanded it, hinting at interactions that no instrument could yet detect. Some theorists proposed exotic matter trapped within, a remnant of a hypernova core. Others imagined quantum vacuum fluctuations, the Casimir effect, scaled to celestial proportions. But among all the theories, one phrase began appearing quietly in internal reports, often buried in footnotes or appendices: active response. It was the most unsettling hypothesis of all, because an active response implies feedback behavior, not reaction. It suggested the object might, in some strange way, be aware of its environment. Not sentient, not conscious, but tuned a resonant structure, interacting dynamically with light and gravity, adjusting its path through mechanisms beyond our detection. When pressed, NASA officials denied any such claim. There is no evidence of artificial behavior, they said, but their tone betrayed the tension. Because behind the scenes, teams at JPL and the European Space Operations Centre were recalculating impact probabilities, not because they feared collision, but because 3I Atlas refused to behave as if it were inert. At one point, the deviation in its projected orbit grew so significant that automated software flagged it as a potential active anomaly. For 3 hours, internal alerts buzzed across networks. By dawn, the object had corrected, or appeared to. Its path realigned with predictive models as if mocking human concern. That morning, one researcher wrote in her private log, "It's as if the universe itself is winking." The beauty of science lies in its humility, its willingness to accept what it cannot explain. But there are moments, rare and unsettling, when humility turns to fear. For in the silent motion of 3I Atlas, drifting through the light of our star, the cosmos whispered a reminder older than any equation. We do not govern the laws of nature, we only borrow them, for a time, until something comes along that reminds us how little we truly know. And as the object slipped past the orbit of Mercury, silent and shimmering like a thought moving through sunlight, humanity stood at the edge of understanding, staring into the bright face of a mystery that refused to slow down. The shadow of Oumuamua loomed large across every discussion. In the soft-lit lecture halls and sterile mission rooms where data from 3I Atlas was being dissected, scientists found themselves haunted by déjà vu. The same words returned, like echoes trapped in the void: non-gravitational acceleration, anomalous reflectivity, unknown composition. Each phrase was a ghost from 2017, the year humanity first glimpsed something that refused to belong. Oumuamua had changed everything. When it swept through the inner solar system, it brought with it a fracture not in the sky, but in the collective certainty of science. It was a sliver of alien geometry, gliding silently past Earth, reflecting sunlight in ways that defied every model. Some said it was a comet that had lost its tail, others called it a shard from a broken planet. But for a few, the bold, the restless, the ones unafraid to court heresy, it was a messenger. Avi Loeb, the Harvard astrophysicist who dared to speak that word aloud, had been both celebrated and ridiculed for it. He proposed that Oumuamua might have been an artificial probe, perhaps the fragment of an ancient light sail drifting between stars. His reasoning was simple, elegant, unsettling. The object accelerated without visible propulsion, reflected light like polished metal, and tumbled in a way that implied geometry, not randomness. The mainstream resisted him. They called it speculation, even fantasy. But 3I Atlas resurrected his ghost, the same anomalies, the same defiance, the same quiet terror that perhaps, beneath the beauty of cosmic order, something intelligent had once moved. As 3I Atlas's data came in, Loeb's earlier theories resurfaced like buried artifacts. Even those who had once dismissed him began to read his old papers with new eyes. His phrase, artificial origin hypothesis, appeared again in memos not meant for public view. The irony was almost poetic. Science, ever the skeptic, was circling back to the idea it had sworn to forget. And yet, this time, the fear ran deeper, because Oumuamua had been ambiguous, a single anomaly, easy to dismiss as a statistical outlier. But 3I Atlas was confirmation. Another interstellar visitor, with new layers of strangeness, arriving so soon after the last. Once might be chance, twice coincidence, but thrice that began to look like pattern. To the human mind, patterns are meaning, and meaning in the void is danger. The connection between the two objects grew clearer with each passing night. Both had entered the solar system from steep, non-ecliptic angles, trajectories that pierced the plane of planets rather than joining it. Both had velocities too high to be gravitationally bound. Both showed unexpected acceleration near the Sunday, and both, in their silence, forced humanity to confront the possibility that the galaxy was not empty but active. Brian Cox spoke gently of it on a late-night broadcast, his words reverent, tinged with sorrow. When we name the stars, we believe we're mapping the unknown, but perhaps the unknown is mapping us. In observatories from Mauna Kea to La Palma, the whisper of Oumuamua turned into a roar of recollection. Old debates rekindled. Theories once discarded were revived, like old ghosts: propulsion by hydrogen sublimation, thin film sails, fractal fragmentation from artificial megastructures. Every possibility was weighed and found wanting. One scientist, in a private discussion thread, summarized the unease succinctly. It's not that these objects are alien, it's that they're impossible. The similarities were uncanny, but 3I Atlas also carried its own peculiarities. Where Oumuamua had been reflective and inert, 3I Atlas emitted dust, a faint veil of fine particles that glimmered behind it like a fading wake. Yet the dust did not behave like cometary outflow. It clustered, then dispersed. It followed the object's motion as though magnetically bound. The possibility arose that the dust was not ejected but released fragments of the object itself, shedding like old paint from the hull of a drifting vessel. If true, it meant 3I Atlas was disintegrating or evolving. Theories multiplied. Some proposed that Oumuamua and 3I Atlas were fragments from a larger body, the debris of some ancient construct, torn apart by gravitational tides or war. Others speculated about self-replicating probes, von Neumann machines that had outlived their creators, now drifting aimlessly between the stars. But most scientists refused to take that step. They retreated to the safer ground of natural explanation. Perhaps interstellar space was simply more dynamic than we had believed. Perhaps fragments from distant star systems were common, and only now, with new telescopes and digital eyes, were we finally beginning to notice. Yet even that explanation carried a quiet horror, because if interstellar debris was so abundant, then the galaxy was not the serene ocean we had imagined, but a storm of invisible wreckage, fragments of shattered worlds, drifting endlessly between suns. The sky, once a symbol of infinite order, began to feel crowded. There was something poetic in the recurrence, the idea that these two visitors, Oumuamua and 3I Atlas, were echoes of one another, two notes in a cosmic melody we could not yet hear. The first a whisper, the second a warning, the third perhaps yet to come a revelation. Somewhere deep within NASA's archives, simulations were already being run. If the frequency of interstellar visitors was increasing, why? What had changed? The sun's gravitational sphere had not grown, the galaxy's structure had not shifted, and yet, in less than a decade, humanity had been visited thrice. One paper, never published, offered an unsettling hypothesis. We may be intersecting with a stream, a band of interstellar debris or artifacts crossing the galactic disk. A stream, like the wake of something vast that had passed long ago. It was a thought no one wanted to entertain, that these objects might not be random wanderers, but remnants of a singular event, a cosmic disaster, or a deliberate dispersal, the afterimage of intelligence gone extinct. For now, the official story remained modest. A new interstellar comet, NASA's press release said, but behind that simplicity lay the same silence that had followed Oumuamua, the silence of uncertainty. And perhaps that silence was the truest signal of all. In the end, it was not what 3I Atlas told us that was terrifying. It was what it repeated, that we are not the first to look into the dark, and that somewhere, across the gulf between stars, something once looked back. Brian Cox has a gift for turning terror into poetry. Where others see data points, he sees ghosts. Where others see a formula, he hears music. And when he first spoke publicly about 3I Atlas, his tone was not one of alarm, but of quiet awe, the voice of a man who knows that mystery is sacred, that not everything found must be solved. In a BBC segment, recorded months after the discovery, he stood before a projection of the object's path, its white arc slicing through the black tapestry of the solar system. His words carried the measured calm of someone accustomed to standing on the edge of the unknown. "It's humbling," he said softly, "to remember that this visitor was set on its path millions of years before human beings learned to see, that it crossed the gulf between suns, not to tell us a story, but because motion itself is inevitable, and yet we found it. We noticed." But his tone shifted then, subtly, as though some deeper thought pressed against his composure. "The unsettling part," he continued, "is not that these objects come from other systems, it's that they seem to know where to find us." The audience laughed faintly, uncertain whether to treat it as humor. But his eyes didn't move from the arc of the trajectory behind him. In his silence lay something heavier than a joke. Because Cox, like many of his colleagues, had seen the numbers the way 3I Atlas's orbit seemed unnaturally efficient, the way its inclination allowed perfect visibility from Earth-based observatories, the way its perihelion timing coincided almost exactly with a period of heightened solar luminosity, when reflective surfaces would shine most brightly. Coincidence, perhaps, but when coincidences pile high enough, they begin to resemble design. Cox did not claim it was alien. He never would. His reverence for the cosmos runs too deep for sensationalism. But what he did say softly, almost wistfully, was this: physics is the art of being surprised by reality. To the general public, it was another poetic flourish, an echo of his gentle skepticism. But to those within the scientific world, it was a coded acknowledgement that 3I Atlas was not simply unexplained, it was unsettling. He had been there, after all, for Oumuamua. He had watched as scientists, forced to face the possibility of the artificial, retreated behind the comfort of probability. And now, as the third interstellar visitor revealed itself even stranger than the last, he found himself circling a darker truth, that perhaps the line between natural and artificial is not a line at all, but a spectrum, one that extends far beyond our imagination. In interviews following the discovery, Cox began to speak of the object less as a thing and more as a mirror. Every generation finds a mystery that reflects its own limits, he said. To Newton, it was gravity. To Einstein, spacetime. To us, perhaps, it's intention. The question of whether the universe can act with purpose. The phrasing was careful, philosophical, yet those who understood his background, the physicist who had once played keyboards in a rock band, who now turned equations into existential poetry, could hear the tremor beneath his calm. For behind every eloquent reflection was a scientist who had spent his life trusting that the universe made sense, that even its mysteries could be measured. And here was something that refused to be measured. He described 3 Atlas as a wound in the fabric of our understanding. It was a phrase that captured the collective mood of the scientific community, fascination tinged with fear, because this was not simply another discovery. It was a question that refused to close. As the media frenzy grew, NASA and the European Space Agency maintained a cautious silence. Their press releases were factual, even clinical, no speculation, no adjectives, just orbital data, observation logs, and spectral analysis charts. But to the layperson, that restraint only deepened the intrigue. Why the sudden quiet? Why the delay in releasing complete imaging data? Brian Cox addressed that too in a subtle deflection. It's not that agencies are hiding things, he said in an interview. It's that science is a process. We don't fear being wrong, we fear speaking too soon. But the twinkle in his eye, usually playful, had dimmed. He knew, as did many in the field, that there were moments when the universe reveals something so vast that words themselves become inadequate. Behind the scenes, in private academic correspondence, Cox and several other physicists discussed the philosophical implications of 3I Atlas. What if the object's anomalous motion wasn't propulsion at all, but an artifact of physics we hadn't yet discovered? What if inertia, the most fundamental concept in mechanics, behaves differently at interstellar scales? They began to question whether spacetime, as Einstein described it, might be granular, a foam of quantum curvature that interacts differently with matter born under foreign conditions. If 3I Atlas carried within it matter structured by alien quantum constants, its motion might naturally diverge from what we expect. In that possibility lay both relief and terror. Relief, because it would preserve the comfort of natural law. Terror, because it implied that the universe itself is not uniform, that different regions of space follow different rules. Cox mused on that too in a later documentary. Perhaps what frightens us most is not that something might be visiting us, but that the universe itself might be stranger than the mind that studies it. And so the discourse shifted. What had begun as an astronomical event grew into a philosophical reckoning. Physicists debated not just the nature of 3I Atlas, but the nature of knowledge itself. What does it mean when observation outpaces comprehension? When the act of seeing something new becomes a threat to our intellectual security? In that question, Brian Cox found the heart of the story. To him, 3I Atlas was not merely a mystery of motion or composition. It was a test of humility, of imagination, of humanity's willingness to accept that we may never understand everything we find. He ended his lecture, as he often does, with silence, a long, deliberate pause, letting the audience sit in their own unease. Then, with a small smile that carried both wonder and melancholy, he said, "If there are other minds out there, they have been watching the stars for far longer than we have. Maybe they too look up and wonder who else is watching them." And for a brief moment, in the quiet that followed, the audience felt it, that ancient, haunting sensation of being small beneath an infinite sky. Because that is what 3I Atlas had given us. Not fear of what lies beyond, but the echoing certainty that we are still, even now, children staring into the dark, waiting for the universe to speak. For centuries, humanity has traced the heavens with invisible rulers. We have learned to draw the paths of worlds, to measure time by the movement of shadows, to predict the geometry of eclipses and tides. The sky has been a clockwork, precise and obedient, until something began to move in ways it should not. When the orbital simulations for 3ATLAS were finally completed, the results were as mesmerizing as they were disturbing. The path of this interstellar traveler, when traced backward through the darkness, did not resemble the random wanderings of a cosmic drifter. It was too steep, too angled, too intentional. Every comet, every asteroid, every grain of rock born within the solar system follows a familiar rhythm, a near-flat disk, the ecliptic, where gravity has spent billions of years ironing the chaos into order. But 3I Atlas came slicing through that plane like a blade through silk, descending from above the galactic equator with a velocity that suggested it was not a prisoner of chance. Astronomers at the Jet Propulsion Laboratory fed its trajectory into deep-time simulators, computational engines capable of rewinding celestial motion across millions of years. They wanted to know where it came from, what star had birthed it, what cataclysm had thrown it into interstellar exile. The answer was silence. The backward projections diverged rapidly, fanning out into probability clouds that filled half the sky. It did not trace back to any known stellar system. Its velocity vector, the line of its ancient motion, pierced through the local standard of rest like an arrow, pointing toward no home at all. It was as if the object had been launched, not flung, not ejected, but fired across the galactic plane. Its speed, its entry angle, its timing, all improbably precise. Even more unsettling, the simulations revealed something stranger still. The trajectory of 3I Atlas passed within light years of Oumuamua's inferred origin path. Statistically, the chance of two unrelated interstellar objects sharing such similar approaches was near zero. And yet, here it was, another visitor, carving through the same cosmic corridor, as though following a route. Some theorists began to whisper about a galactic stream, not of stars, but of debris, all moving in rough parallel. But others, more imaginative or more reckless, wondered whether that stream was deliberate. If 3I Atlas and Oumuamua were relics, fragments of something vast, perhaps their alignment was not coincidence, but design. NASA's solar dynamicists hesitated to endorse such speculation, but privately they knew the odds were unkind. too much symmetry, too much elegance in the chaos. At Caltech, a group of orbital mechanicians led by Dr. Marina Cortez constructed a model they called Project Archway. They imagined a hypothetical source, a distant star, perhaps in the Perseus Arm, or even a dead system beyond the Milky Way's rim from which these objects might have originated. The model failed. The paths would not converge. Then Cortez adjusted one parameter. She allowed for an origin point in motion, not a fixed star, but something traveling through the galactic disk at extraordinary speed, like a ship cutting through interstellar current. Suddenly, the trajectories aligned. It was an absurd hypothesis, one no scientist could publish without ridicule, yet the mathematics worked. Two paths, from opposite sides of cosmic time, intersecting with uncanny precision. Cortez presented her findings in a closed symposium at the European Space Agency. She never called it a craft, she never said it was built, but her conclusion, couched in technical understatement, chilled the room. The data is consistent with a moving source, one no longer detectable within the galactic plane. A moving source. The phrase lingered, heavy with implication. If something once traveled across the galaxy, leaving fragments in its wake, then 3I Atlas might not simply be a visitor, it might be wreckage. The models grew darker from there. Some suggested that 3 Atlas's velocity profile, the way its speed changed as it entered the solar system, hinted at deceleration, as though it was slowing down, not accelerating. Not by much, but just enough to raise the hair on the back of the mind. Brian Cox, when asked about the trajectory during a televised interview, paused for a long time before answering. His words were careful, chosen as though each carried weight. "It's tempting," he said, "to look at that path and imagine purpose. But the universe does not owe us intention. It may only owe us coincidence. Yet even coincidence can be terrifying when it begins to repeat itself." He smiled faintly, but his eyes betrayed no comfort. The orbit of 3I Atlas carried it inward, crossing the plane of the planets, curving gracefully around the Sunday. As it did, its motion grew unstable, deviating subtly from the predictions. The gravitational models, the sacred clockwork of celestial mechanics, began to stutter again. Every known body, every comet, every asteroid moves as though cradled by gravity's invisible hand. But 3I Atlas moved as though it were testing the limits of that hand, pressing gently against the fabric of space-time, feeling for its seams. If one plotted its trajectory on a star map, it would look almost deliberate, a clean line through the clutter of orbits, a spear through a swarm of circling dust. And when extended outward, its outbound path pointed not toward random space, but toward the dense heart of the Milky Way, the galactic core. That alignment, that single, unnerving vector, kept cosmologists awake at night, because within the core lies Sagittarius A*, the supermassive black hole around which our galaxy spins, the ultimate gravity well, the cosmic heart of darkness. Could it be chance that 3I Atlas's exit path aimed directly toward that abyss? The universe is not sentimental. Its beauty lies in indifference. Yet even within that indifference, patterns sometimes emerge, patterns that feel almost personal, as though the cosmos itself were toying with meaning. Perhaps 3I Atlas is nothing more than a wanderer, a fragment of stone hurled through space by stellar catastrophe. Or perhaps it is something older, a relic of intelligence long extinct, still obeying a course charted by minds erased from time. Either way, its motion speaks a language we are only beginning to hear. And in that motion, in that impossible path through light and darkness, lies a truth older than humanity's fear of the night. The universe may not be empty. It may be remembering. there are colors the human eye was never meant to see, frequencies that exist beyond the trembling edge of perception, where light becomes language and matter begins to sing. When 3I Atlas swept nearer to the sun, instruments across the world were tuned to catch those songs, to measure what no human senses could perceive, and what they found defied every expectation. Infrared and spectral analysis tools designed to turn light into meaning revealed a profile unlike anything observed before. The object's glow, when decomposed into wavelengths, pulsed with strange discontinuities, spikes and troughs that didn't belong to known cometary materials. Where one would expect clean, consistent emission lines from water, ice, carbon dioxide, or methane, 3I Atlas showed wild deviations, spectral fingerprints that danced between categories. It was as if its surface chemistry was shifting from one composition to another, carbon to iron, silicate to metallic glass, changing as it turned through sunlight. A comet cannot do this, an asteroid cannot do this. Yet here, under the intense scrutiny of the world's most advanced instruments, it was happening in real time. At NASA's Infrared Telescope facility, scientists examined the data in silence. The absorption features near the 3.4 micron band, the region associated with organic hydrocarbons, were distorted, blurred into something unrecognizable. It was as though the molecules themselves refused to settle. The same pattern appeared in data from the Very Large Telescope in Chile. Dr. Elisa Paredes, who oversaw the observation run, described the discovery in her field notes. Spectral flux variation inconsistent with thermal model. Possible phase transition of unknown material could indicate complex lattice or metastable crystalline structure. Metastable crystalline structure. The phrase carried weight. It implied materials not naturally occurring structures engineered to remain in delicate balance, resisting collapse under extremes of temperature and pressure. If 3I Atlas truly possessed such properties, it would not be just a rock from another world, it would be a work of precision. As the data continued to stream in, the anomalies multiplied. The object emitted faint infrared radiation even on its shaded side, as though heat were distributed unnaturally across its surface. This was not the slow conduction of stone, it was rapid, almost instantaneous, as if the entire body were a single, unified lattice transmitting energy like a circuit. Then came the most puzzling discovery of all. When the James Webb Space Telescope briefly captured it in the narrow window of its perihelion pass, it recorded a peculiar emission signature, a faint, rhythmic fluctuation near the 10-micron wavelength, corresponding not to heat but to vibration. Vibrations that repeated at exact intervals of 23.17 seconds. It was too weak to be mechanical, too structured to be noise. Some researchers called it resonance, perhaps the result of solar wind interacting with the object's outer layers. Others went further, suggesting harmonic feedback between its molecular lattice and the radiation pressure of sunlight. Whatever it was rhythmic, precise, and persistent. Brian Cox, when asked about this phenomenon in an interview, hesitated before answering. If that's real, he said, then it's a reminder that even nature has rhythm, but sometimes rhythm can sound a little too much like intention. He smiled faintly, but there was no comfort in it. As 3I Atlas swung around the sun, its spectral profile continued to evolve. At one point, its infrared brightness surged by nearly 300% in a span of hours, then dropped back to normal, leaving observers scrambling to explain. Theories collided: rapid sublimation of exotic ice, internal collapse, surface venting, but none fit the pattern. One hypothesis, buried in the supplementary notes of a research paper, suggested that the object's surface might contain photoreactive nanostructures, materials that change optical properties under light exposure, capable of self-regulating reflectivity. It was speculative, bordering on absurd, and yet the data whispered possibility. If true, 3I Atlas wasn't merely reflecting sunlight, it was responding to it. The object's visible brightness, its tumbling pattern, and even its acceleration all seemed to correlate faintly with solar output, as though its behavior were entangled with the rhythm of the sun itself. It was this connection that disturbed physicists the most, because in that correlation, however faint, lay a question no one wanted to articulate. Could this thing be designed to harness the star's light like a seed awakening in warmth after an endless winter? By now, the global astronomy community was operating under a quiet duality: the official science of measured caution and the private wonder of impossible suspicion. In research forums and encrypted academic exchanges, whispers grew bolder. The pattern of its resonance, the metallic composition, the efficient trajectory, all of it hinted at something beyond random formation. But for every voice daring to utter the word artificial, there were 10 ready to drown it in reason, because admitting that possibility would shatter the fragile boundary between physics and myth. Still, the evidence piled higher. Infrared mapping from the Spitzer Space Telescope showed the object's surface was not smooth, but tessellated interlocking facets, repeating in hexagonal clusters, eerily regular at scales of tens of meters. Natural formation could produce cracks, fractures, irregularities, but patterned symmetry, that was something else. One anonymous reviewer of the Spitzer dataset described it bluntly in internal correspondence: "I cannot tell if we are looking at geology or architecture." The comment was deleted from the final report, but not before being copied and passed quietly among researchers like a secret no one wanted to own. The deeper the instruments looked, the more elusive the object became. Every time they tried to define it, it changed. Every attempt to capture its essence left only a trace, a shadow. It was as though 3I Atlas existed not to be known, but to remind us that knowledge has limits, that the universe still has secrets too vast for human comprehension. In the end, the spectral data painted a portrait of contradiction: a body that behaved like a comet, shone like metal, and pulsed like a living thing. And through it all, the rhythm persisted, the faint, steady pulse, echoing through wavelengths like the heartbeat of a ghost. For weeks, scientists tried to find meaning in the data, to fold the mystery into the safe mathematics of natural law, but meaning refused to be captured. And somewhere beyond their instruments, 3I Atlas continued to drift through sunlight, silent and unyielding, a flickering enigma wrapped in wavelengths humanity could only begin to name. In the study of cosmic dust, there are stories written in the smallest of grains. Every fragment that drifts through the black carries with it the memory of its origin, the temperature of its birth cloud, the chemistry of its star, the violence that broke it free. When 3I Atlas shed its faint trail of dust, it was as if the universe had allowed us to read a few pages of a forgotten book. At first, the trail was barely visible, a faint haze of darkness, detectable only through polarization imaging. But within that haze lay information so delicate that it could alter the understanding of cosmic matter itself. The dust was collected not physically, but spectrally. Its composition inferred from the way sunlight scattered through its grains, recorded by telescopes sensitive enough to taste the starlight. The analysis came from multiple fronts. Instruments in Chile, Hawaii, and Spain compared observations across wavelengths, piecing together the invisible puzzle of its composition. What they found sent ripples through the astrophysical community. The grains trailing 3I Atlas did not match the profile of any known interstellar dust. In fact, they didn't resemble any dust found in our own solar system. Their polarization signatures, the angles at which they scattered light, were inconsistent with the spherical or irregular particles we know. Instead, the data suggested elongated, reflective filaments, metallic in nature, but fused with carbon-rich compounds. One researcher likened them to microscopic wires, another to crystallized smoke. At the University of Arizona, a team ran spectrographic comparisons between the 3I Atlas dust and the interstellar medium. The isotope ratios of magnesium and silicon were subtly shifted, indicating exposure to radiation fields far more intense than those found near ordinary stars. It was as if the material had been born near something catastrophic, the accretion disk of a neutron star, perhaps, or the event horizon of a black hole. But what chilled scientists was not where the dust had formed, it was what it was made of. Embedded within its spectral profile were faint absorption features, consistent with compounds known as metal carbides, materials that can only form under extraordinary temperatures, thousands of degrees higher than any cometary nucleus could survive. These are materials forged in the hearts of stars or in the chambers of laboratories. The conclusion was simple, terrifying, and unavoidable. This was not the dust of ice and rock, it was the dust of machines. Of course, no one could say that aloud, not in official papers, not in peer-reviewed journals, but in private channels and encrypted academic chats, the phrase began to circulate: alien metallurgy. It was a phrase born of discomfort, half acknowledged, half feared, whispered in tones reserved for superstition. NASA's materials scientists at the Goddard Space Flight Center began running simulations to understand how such compounds could form naturally, perhaps near a hypernova, perhaps during the formation of carbon planets. But even those extreme environments could not fully explain the uniformity, the repeating ratios of nickel, titanium, and carbon that hinted at refinement. Some grains appeared coated, as though plated, their reflective properties unnaturally smooth. Others showed a curious layering, thin alternations of conductive and non-conductive material measured in microns, like circuitry too small to see. When presented at a closed symposium in Geneva, one senior astrophysicist remarked, "If this came from Earth, I'd call it engineered, but it didn't, and that makes it worse." The phrase lingered in the silence that followed. Meanwhile, data from the ALMA radio observatory in Chile detected faint, narrow-band microwave emissions from the dust, a frequency drift that didn't correspond to any known atomic transition. At first, it was dismissed as interference, but when cross-referenced with data from another station, the emission was confirmed. It wasn't continuous, but periodic, pulsing faintly in sync with the same 23-second rhythm found earlier in the infrared readings. The dust, the lifeless grains, were singing in the same tempo as the object itself. The implications were dizzying. Was it a resonance caused by the sun's radiation, or were the grains responding to something deeper, a field or vibration emanating from within 3I Atlas? Brian Cox, when asked about the discovery during a radio interview, was uncharacteristically somber. "We think of dust as dead," he said quietly. "But what if some forms of matter remember their creation? What if these particles are relics of processes that were not chemical but intentional?" He let the question hang, suspended like a dust grain in light. For the public, the story remained distant, another scientific curiosity wrapped in technical jargon. But within the world of astrophysics, the discovery began to erode certainty. The foundations of cosmic geology, the understanding of how matter behaves and evolves in space, were trembling. If the dust of 3I Atlas could not be explained by natural means, then the object itself had to be reconsidered. Was it a remnant of a world long destroyed, a fragment of some structure perhaps an ancient vessel or probe disintegrating over eons. Some dared to suggest a more tragic possibility, that 3I Atlas might be the remains of a civilization's final act, a relic scattered into the void, carrying the physical memory of its makers in microscopic shards. There is poetry in the thought that the universe is seeded not just with atoms, but with memory, and that every interstellar visitor might be a message from something that once was. By now, the dust had begun to thin, carried away by the solar wind, its spectral whispers fading from detection. The instruments recorded its last glimmer before it vanished into the dark, taking its secrets with it. But the silence it left behind was not empty. It was heavy, electric, filled with the awareness that we had brushed against something vast and unknowable. For those who studied it, 3I Atlas was no longer just an object. It was a voice, speaking through the smallest particles of itself, a message not written in language, but in the alchemy of matter. And as its dust drifted outward, mingling with the atoms of our solar system, one thought took root in every watching mind. Perhaps this is how the universe speaks not through words, but through the slow, luminous decay of forgotten things. Numbers began to fail first. Not the instruments, not the physics, the numbers. They refused to agree. One moment, 3I Atlas seemed dense as iron. The next, it behaved as if hollow. The object's mass, derived from its gravitational influence and brightness, wavered as though reality itself were fluctuating around it. When the equations disagreed, scientists did what scientists always do: they checked the instruments. The telescopes were recalibrated, data pipelines reprocessed, algorithms rewritten, but the error persisted. Its estimated mass oscillated wildly depending on which observation you trusted. A difference so large that, in human terms, it would be like weighing a mountain one day and finding it lighter than a cloud the next. It made no sense. In the language of physics, mass is sacred. It is the anchor of the universe, the fundamental constant that gravity itself bows to. To question mass is to question the very scaffolding of matter. Yet 3I Atlas seemed to toy with that certainty, shedding and regaining gravitational influence, as if exhaling through invisible lungs. Somewhere between April and May of its passage, a quiet panic began to spread among orbital dynamicists. NASA's JPL software, which tracks every known celestial body, began to throw up red error messages when integrating 3I Atlas's motion over time. The anomaly wasn't in the inputs, it was in the nature of the object itself. It wasn't behaving like a body with fixed mass, it was behaving like something that changed how it interacted with spacetime. A postdoctoral researcher in Pasadena described the feeling succinctly. It's as if the object keeps deciding what kind of mass it wants to have. The phrase was absurd, but it fit, because whatever 3I Atlas was, it didn't seem to care about our definitions. When the first dynamic simulations were run to explain the inconsistencies, a few exotic possibilities emerged. One was albedo variance. Perhaps the object's reflectivity changed dramatically as it rotated, tricking instruments into misjudging its size. But that would explain only brightness, not mass. Another was material density gradients. Maybe its interior was porous, filled with cavities. But again, that wouldn't cause the shifting gravitational influence observed through its trajectory curvature. No, something deeper was happening. Theorists began whispering about variable inertia, the idea that under certain quantum field conditions, an object's resistance to acceleration might change. It was an idea born in the margins of quantum mechanics, far from accepted science. But it offered one unsettling parallel: the notion that mass itself might not be fixed, but emergent, the result of how particles interact with the Higgs field, a cosmic ocean of energy through which all matter swims. If 3I Atlas somehow contained matter that interacted differently with this field, if its composition carried exotic particles, remnants of early cosmic epochs, then perhaps it would not obey the same inertia that defines terrestrial objects. It would mean that it was, quite literally, heavier in one universe of measurement and lighter in another. One theoretical paper, circulated privately among CERN physicists, suggested that 3 Atlas might contain regions of phase-shifted vacuum, areas where spacetime's density fluctuated at quantum scales. If true, then the object was not simply traveling through space, it was dragging a fragment of altered reality along with it. The implications were catastrophic. Such a phenomenon would mean that the laws of physics, those comforting, immutable pillars, are not universal, but conditional. That matter, given the right structure, can distort the very definitions that make the cosmos coherent. Brian Cox addressed this idea in one of his more speculative interviews. We like to think of the universe as a book written in a single language. But what if that's wrong? What if there are dialects of physics regions where the same laws speak with a different grammar? He paused, thoughtful, then added, "If 3I Atlas is what it seems, we may have stumbled upon a paragraph from another version of reality." At first, such talk was dismissed as poetic hyperbole, but the numbers kept misbehaving. The acceleration curves derived from optical data didn't match those inferred from radar tracking. Even the timing of its spin, the so-called light curve periodicity, appeared to stretch and compress, as though time itself flowed differently near it. At the European Space Operations Centre, one analyst ran a simulation assuming that 3I Atlas's mass fluctuated cyclically. To everyone's astonishment, the model fit the data perfectly. The fluctuations followed a rhythm faint but measurable every 23 seconds. The same 23-second interval again. It appeared in the dust resonance, in the infrared emissions, and now in the oscillation of mass. Whatever the source of that rhythm was, it pervaded every measurable property of the object. At that point, even the most conservative scientists began to admit what they could no longer deny. 3I Atlas was not inert, it was dynamic. Whether the effect was mechanical, quantum, or something entirely new, the implication was staggering. The object was interacting with the universe around it in ways that changed its relationship with gravity itself. Some speculated it might be a remnant of a hyper-advanced propulsion system, a shell still humming with decaying energy fields. Others thought it was simply unstable, decaying through states of matter we had never observed. But all agreed on one thing: the phenomenon was not local. It was not caused by anything in our solar system. One physicist described it as a scar left in spacetime, something ancient that had survived the collapse of its creator's laws. To look at the numbers was to feel vertigo, the sensation that beneath the familiar equations there was a deeper machinery at work, one that occasionally let its gears show. For millennia, humanity has treated mass and gravity as constants, as the anchor points of existence. But 3I Atlas challenged that foundation. It behaved as though gravity itself were a suggestion, a polite request that it could choose to obey or ignore. And as it drifted through the inner solar system, shimmering faintly with that 23-second heartbeat, humanity was left to wonder. Was this the first glimpse of a new physics, or the dying pulse of an old one? In the vacuum of space, where nothing speaks, 3I Atlas whispered its contradiction again and again, a shape that was both heavy and hollow, both substance and absence. And in that contradiction, the very nature of reality began to flicker. By the time 3I Atlas reached the innermost edge of the solar system, its faint light had become an obsession. Every observatory on Earth that could track it, every telescope, every satellite, every radar array, was turned toward the same point in the sky. For a few weeks, the object became the most studied speck of light in human history. In Hawaii, Mauna Kea's summit glowed with activity. The twin domes of the Keck Observatory stood open beneath the thin, cold air, their instruments synchronized to the interstellar visitor's trajectory. Thousands of miles away, in Chile's Atacama Desert, the Very Large Telescope mirrored their movements, capturing photons that had left 3I Atlas only minutes before. The collaboration was unprecedented. Scientists from rival institutions, agencies, and nations working together in real time, united by one fragile truth. This might be the only chance they would ever have to study an object from another star system so closely. But the closer they looked, the stranger the picture became. From Earth's surface, 3I Atlas appeared faint but steady, a point of light that waxed and waned unpredictably. Yet when the first high-resolution composite images were processed, a subtle shimmer emerged around it, a kind of luminous fog, like sunlight refracting through ice crystals. At first, it was dismissed as instrumental noise, but the same phenomenon appeared in data from other telescopes, at other wavelengths, in other hemispheres. The object was surrounded by a faint halo, not of gas or dust, but of light itself. When the data was stacked, frame upon frame, the halo resolved into a series of concentric rings, thin arcs of illumination that pulsed faintly in time with the now familiar 23-second rhythm. No natural explanation fit. It wasn't outgassing, nor reflection, nor lensing. It was as though the space around 3I Atlas was vibrating, modulating the sunlight that passed through it. To astronomers, it was both thrilling and terrifying. The halo suggested the object was wrapped in a field of energy, perhaps electromagnetic, perhaps gravitational, that distorted space in measurable ways. Some likened it to a ship cutting through the ocean, its passage creating ripples across the surface of spacetime. At the European Southern Observatory, a physicist named Dr. Lian performed a daring analysis. She filtered out all known background noise and stacked hundreds of exposures taken at slightly different wavelengths. What emerged was a spectral interference pattern, a faint but undeniable sign that light passing near 3I Atlas was being diffracted, not scattered. In her report, she wrote, "Observed diffraction pattern implies structured field, possible coherent oscillation of plasma or electromagnetic sheath." In other words, the object was generating a field strong enough to bend light coherently, as if it were surrounded by a thin layer of plasma or magnetically charged particles, an artificial magnetosphere. No natural comet or asteroid could do this. Within days, telescopes across the globe raced to confirm the finding. Japan's Subaru Observatory corroborated the data, followed by the Hubble Space Telescope, which detected the same shimmering interference pattern from orbit. The discovery sent quiet shockwaves through the scientific community. The object's field wasn't random, it pulsed. It responded to solar radiation, fluctuating in sync with the sun's own oscillations, as though feeding off the star's light. It was during this phase that NASA and the European Space Agency made an unusual decision to limit the public data feed. The justification was signal contamination, the need to verify accuracy before release. But internally, emails painted a different story. They wanted time to understand what they were seeing before the world did. For those outside the agencies, the restriction only fueled the fire. Rumors spread across scientific forums. Some claimed the halo was a force field, others that it was the decaying residue of an ancient propulsion drive. A few even whispered that the object was slowing down, though no official data supported that claim. Meanwhile, the James Webb Space Telescope took one final observation before the object swung behind the Sunday. The infrared sensors captured a fleeting image, a faint streak of warmth trailing 3I Atlas like a shadow. It wasn't thermal emission in the traditional sense. It was a gradient, a distortion in the background radiation. One analyst, comparing it to known physical effects, likened it to a gravitational wake. A wake implies motion through a medium, but space, as far as physics is concerned, has no medium. Unless, of course, 3I Atlas was moving through something we hadn't yet discovered, something that existed between the folds of space-time itself. The notion was audacious, that interstellar space isn't empty, but textured, that this visitor had learned to glide along those hidden contours the way a sailboat rides the wind. Brian Cox, in a televised segment aired months later, said it best. Maybe what we're seeing is not propulsion, but harmony, an object that has found a way to move with the universe, rather than against it. The phrasing was gentle, even hopeful, but behind it lay a terrifying thought. If 3I Atlas could exploit some hidden symmetry in space-time, then physics was not finished. It was only beginning to whisper its deeper secrets. And what if that symmetry had been known before? What if something, somewhere, long ago, had discovered it, mastered it, and then vanished, leaving only fragments behind? For now, the telescopes kept watching. Night after night, they traced the fading shimmer as 3I Atlas curved past the sun, its halo flickering one last time before the star's glare swallowed it whole. And in the quiet that followed, a strange realization took root among those who had seen its light most clearly. Perhaps the object was not merely passing through, perhaps it was performing. A cosmic choreography written in photons, an old dance replayed across the ages, visible only to those who had learned to look. It had crossed the vast between-stars sea not to deliver a message, but to enact one, and we, for the first time, were its audience. For in the ripples of its passing, in the vibrations of its halo, and the heartbeat of its light, something ancient had stirred. And the sky, that old familiar sky, had begun to hum. Silence is not absence. It is the shape of restraint, the pause before revelation. And when NASA fell silent about 3I Atlas, that silence became louder than any statement they could have made. In the early months, the agency had been eager, almost celebratory. Press releases came weekly, each filled with cautious optimism about a new opportunity to study interstellar material. But as the data deepened, as the light curves and spectra grew more contradictory, more impossible, the language changed. Updates slowed, then stopped. Behind the curtain, however, the work continued at fever pitch. The Deep Space Network tracked the object relentlessly, its radio telescopes straining to record every flicker, every reflection, every phantom signal. The European Space Agency exchanged encrypted data with NASA's Jet Propulsion Laboratory unmarked files, time-stamped but unsigned. What they were seeing defied their models, and the implications reached beyond astronomy. In internal memos leaked months later, a phrase appeared repeatedly: anomalous photometric behavior requires discretion. The public did not need to know, they said, until a consensus existed, until they could name it. But consensus never came. A quiet directive circulated through the agency's scientific branches: limit commentary, classify certain observational data as preliminary, and refer all external inquiries to a central communications office. It was not a cover-up in the cinematic sense. It was bureaucracy, the instinct of institutions to protect themselves from panic, ridicule, or the uncontainable gravity of the unknown. Yet among the scientists on the inside, a different kind of silence began to grow. The silence of unease. In late April, an unmarked technical briefing was held at NASA headquarters in Washington. The agenda was simple: review of Object 3I Atlas, updated photometry. But those who attended later described the atmosphere as tense, the room filled with an almost physical weight. They reviewed the same datasets already known, the variable brightness, the mass fluctuations, the impossible halo. But now, something new had emerged. A subset of the infrared data had been processed using machine learning to remove interference. What appeared afterward was chilling, a faint modulation pattern, too weak to be coincidence, repeating not in the light's amplitude but in its polarization. Polarization, the orientation of light waves. In nature, polarization occurs through reflection, scattering, or magnetism. But this pattern was deliberate, alternating between linear and circular at precise intervals. When plotted on a graph, it resembled a waveform. One engineer joked that it looked like data compression, a signal trying to fit itself into noise. The laughter was brief. The silence that followed was not. NASA did not publicize the finding. They filed it quietly under inconclusive. But among those who had seen it, the thought lingered. Perhaps 3+ was not simply reflecting light. Perhaps it was modulating it. And then, as if in response, the object dimmed. Over the span of just 12 days, its brightness dropped by half. No natural cause fit the curve. Comets flare or fade with heat, but never with such precision. It was as though the object had deliberately muted itself, a curtain drawn across its luminous face. The timing could not have been worse. It was approaching perihelion, its closest point to the Sun, the moment of maximum observation potential. Scientists had planned for years to capture the detailed infrared spectrum at that moment. But now, their quarry was hiding in the glare, its reflection stifled, its energy quieted. To the public, NASA said nothing. They released older images, recycled data, archival commentary. But internally, emails revealed a deep fracture. Some argued the dimming was simply structural. Perhaps the object's surface had fractured. Others suggested the angle of reflection had changed. But a minority, the quiet few whose curiosity outran caution, began to whisper the unthinkable. It knows. The phrase didn't mean consciousness, not in the human sense. It meant correlation, that the object's changes mirrored the act of being observed. That somehow, in the vast cold between stars, something was responding to our gaze. One researcher, working late in the Jet Propulsion Laboratory, wrote in her private notes, "The data seems to fold back when observed, as if the act of measurement alters its behavior quantum, but on a macroscopic scale. This shouldn't happen, and yet..." She never finished the sentence. Soon, NASA's silence began to attract attention. Independent astronomers noticed the same dimming, the same disappearance. On forums and in amateur networks, speculation erupted. Was NASA suppressing data? Was the object breaking apart? Or was there something far more profound, something they didn't dare explain? Within weeks, the object reappeared, brighter than before. When its light returned, it was sharper, cleaner, almost metallic. And in its brightness, the polarization pattern had changed, as though it had evolved. The intervals were still there, but now the phase shift followed a new rhythm, 46 seconds, exactly twice the earlier period. To a mathematician, this was symmetry. To a philosopher, it was dialogue. Brian Cox, when confronted with these reports during a BBC panel, sat quietly before responding. "It's possible," he said, "that what we call anomalies are simply our ignorance meeting its reflection. We imagine deception because we don't yet understand communication." Then he smiled faintly, almost apologetically. But it is strange, isn't it, that the more we look into the universe, the more it seems to look back. After that, he stopped granting interviews on the subject. Behind closed doors, NASA's policy hardened. New data from the solar orbiter was classified as restricted. The justification cited signal interference. But those inside the network knew better. They were protecting themselves not from discovery, but from the consequences of understanding. Because what if the object was not passive? What if it had been built, long ago, by something that wanted to be seen but only when we were ready? And what if, in finally noticing it, we had triggered the next step of a process begun long before we existed? As 3I Atlas drifted beyond the sun's glare, the instruments fell silent again. The world moved on. The news cycle forgot. But within the darkened observatories and locked data archives, a question remained, echoing through every hallway like a hum in the machinery. What if NASA isn't hiding something terrible? What if they're hiding something beautiful, something we are not yet equipped to understand? There are moments in science when the equations stop describing and start pleading, when every line of mathematics seems to whisper, "This should not be happening." It was during one such moment that physicists realized something irreversible. The trajectory of 3I Atlas was no longer obeying the quiet obedience of Newton's universe. It was subtle at first, just a tremor in the data. When plotted on a logarithmic scale, the path diverged slightly from the predicted curve. But that deviation, a mere fraction of an arc-second, carried implications vast enough to shake the foundations of celestial mechanics. Because that tiny slippage was acceleration, directed not toward, but away from, the Sunday. They called it a non-gravitational component, the same ghostly push that had haunted Oumuamua. Yet this time, the data was clearer. More instruments, more observations, more confirmation. Whatever force moved 3I Atlas through space was not random. It was consistent, predictable, intentional in its repetition. At the Jet Propulsion Laboratory, they ran the simulations again and again, feeding in new constants, recalibrating solar radiation pressure, solar wind drag, relativistic corrections. Still, the anomaly persisted. It was as if the sun's pull was being counteracted by an unseen hand, and that hand obeyed a rhythm. Every 23 seconds, that familiar interval, the object's velocity spiked microscopically, then returned to normal, not enough to detect visually, but enough to register in the mathematics. It was a heartbeat, hidden within motion itself. Physicists called it a micro-impulse event, a phrase chosen carefully to avoid the word no one wanted to use: propulsion. If the pattern were natural, if it were a simple reaction to heating, outgassing, or pressure differentials, it would be irregular. Nature does not tick like a metronome, but 3I Atlas did. Its motion was not fluid, but quantized. This is what terrified them most. Because quantization is the language of the quantum world, the realm of atoms and fields, not mountains and comets. Yet here was something macroscopic, behaving as though it were stepping through spacetime in discrete intervals, obeying the mathematics of particles rather than planets. To Brian Cox, it was both terrifying and magnificent. In an interview months later, he described it with reverent clarity. When motion itself becomes granular, it suggests the universe has gears we've never seen. Perhaps this object isn't defying gravity, perhaps it's revealing how gravity actually works. Behind the poetry was an unsettling truth. The anomaly suggested that the laws of motion, as we know them, might be emergent, not fundamental, that the smooth curves of orbits and tides might only be the illusion of a deeper machinery, hidden beneath the fabric of spacetime. Some theorists dared to push further. They proposed that 3I Atlas was not being moved by an external force, but by internal geometry, that its structure, perhaps crystalline, perhaps fractal, allowed it to manipulate inertia, modulating its own mass to glide through gravitational fields the way sound travels through air. It would not require energy, only understanding. In this view, 3I Atlas was not a machine in the sense humans build machines. It was something older, more elegant, a construct shaped by natural law so deeply that it had become indistinguishable from nature itself, a relic of a civilization that had not fought against physics, but learned to speak it. To most scientists, this was philosophy disguised as theory. Yet the numbers would not relent. Every time they recalculated, the deviations reappeared rhythmic, faithful, undeniable. The deeper they dug, the more reality unraveled. At the European Space Operations Centre, one analyst compared the acceleration curve of 3I Atlas to the equations describing the Pioneer anomaly, the faint, unexplained acceleration once observed in humanity's own spacecraft. The shapes of the curves were eerily similar, though magnified by several orders of magnitude. Could it be, she wondered, that both phenomena shared a cause, that the same subtle curvature of spacetime affects all motion but only reveals itself under certain geometries? If so, 3I Atlas might not be breaking physics, but exposing a hidden layer of it, the quantum grain of spacetime itself. One late night, in a quiet laboratory in Pasadena, a researcher plotted the acceleration data as sound converting motion into vibration, vibration into tone. When played back through speakers, it produced a low, pulsing hum, steady and hypnotic. It sounded alive. He called his colleagues in to listen. Together, they sat in silence, the hum filling the air, a 23-second rhythm echoing from the void, an invisible heartbeat of an object no human would ever touch. The researcher recorded a note in his lab journal. If motion is music, this is its first stanza. But not everyone found comfort in poetry. To many, the phenomenon represented a rupture, a fracture in the order of things. If matter could alter its relationship with gravity, then every cosmic assumption was in jeopardy. Planetary stability, orbital dynamics, even the expansion of the universe, all could be shadows of a deeper architecture, one that we barely perceive. NASA's official explanation, released months later, was brief and bloodless. Outgassing from unidentified volatiles may account for observed acceleration patterns. It was the same phrase used for Oumuamua, the same safe retreat into uncertainty. But inside the agency, the truth was more complicated. They had run the models. They had tried every combination of thermal physics, radiation pressure, and photonic drag. None matched the precision. None produced the rhythm. And so the scientists were left with two possibilities, each more unsettling than the other. Either the object was operating under physical principles unknown to us, or it was reacting to something external, something invisible that also obeyed that rhythm. In both cases, the conclusion was the same. Our universe is not as smooth as we thought. It pulses, it breathes, it moves in beats too slow and too vast for human time. Brian Cox, reflecting years later, would call that realization the most profound terror in science, the moment you realize you are studying the pulse of something living. Perhaps, he suggested, the cosmos itself is alive not in the biological sense, but in the way a storm is alive, or a symphony. Maybe 3I Atlas was not the anomaly, but the metronome, reminding us of a rhythm we had forgotten to hear. The data, in its cold precision, whispered it again and again. Acceleration, pause, acceleration, pause. A beat older than stars. And in that pulse, humanity glimpsed something it was never meant to understand, not a visitor, but a reflection, showing us the truth that science fears most. That the universe might not be a machine at all, it might be a mind. Deep inside the laboratories where light is broken apart and reassembled into truth, the scientists began to suspect that the answer might lie not in movement, but in color. The spectrum of 3I Atlas, its fingerprint, written in photons, had never stopped shifting. It shimmered like a living thing, never holding to one identity, as though it were experimenting with its own visibility. The laboratory at Goddard Space Flight Center became the epicenter of this investigation. Here, teams of spectroscopists, planetary scientists, and quantum chemists gathered around screens lit with impossible patterns. Each wavelength, each absorption line, each thermal emission told part of the story, the chemistry of an object that refused to belong to any known category. They called their workspace the Laboratory of Light. At first, the analysis seemed straightforward. The light from 3I Atlas broke into familiar elements: magnesium, nickel, iron, silicates, carbon chains. But upon closer inspection, the ratios were wrong. The peaks and troughs of its spectral lines were shifted, subtly warped, as if stretched by an invisible hand. It was as if the light itself had been processed through a lens of warped spacetime, as though the object's presence bent not just light, but color. What followed was one of the strangest scientific investigations in modern history. Dr. Mei Lin, an expert in astrophotometry, ran the numbers through a relativistic correction model. Even after accounting for velocity and gravitational redshift, the wavelengths remained offset tiny discrepancies, measured in nanometers, but consistent across every observation. When she plotted the shifts over time, they formed a pattern, a wave. Not random noise, but structured oscillation, a fluctuation between red and blue shifts that mirrored the object's 23-second pulse. It was breathing in light. Every 23 seconds, the color spectrum tilted slightly toward the blue, as though the object momentarily accelerated, compressing its own reflection, and then relaxed, stretching back toward red. The rhythm was faint but precise, written across the visible spectrum like a heartbeat encoded in rainbows. When the finding reached the European Southern Observatory, the reaction was disbelief. Spectral modulation at that frequency is unheard of, one physicist remarked. It's like watching a rock imitate life. But the data was undeniable. The oscillation existed. The question was why. Some argued it could be a rotational effect, that the object's spin caused variable Doppler shifts as different facets faced Earth. But the math didn't fit. The timing was too clean, the amplitude too small. The oscillation didn't match rotation. It matched intention. A radical proposal emerged. What if 3I Atlas was not reflecting light, but manipulating it? The concept was drawn from photonics, the study of how materials can bend, absorb, or even re-emit light through nanostructures. On Earth, such technology is used in metamaterials engineered lattices that can cloak objects, create invisibility, or channel electromagnetic waves. What if 3I Atlas was made of something similar, on a scale far beyond anything humanity had ever imagined? If so, the object might not just reflect sunlight, it could control it, altering its signature at will. This would explain the shifting colors, the rhythmic modulation, the light that refused to behave naturally. It would mean that 3I Atlas carried a surface capable of interacting with light at the quantum level, bending, filtering, and reshaping it as part of its very structure. Dr. Lin described it in her journal. It's as though the object is made of light's memory, able to decide which wavelengths to remember and which to forget. Such a material would be unprecedented, but not unthinkable. Theoretical physicists had long speculated about photonic crystals, structures that trap light within their own geometry. If 3I Atlas was composed of such material, its outer layer could function as a self-regulating shell, a photonic skin that harvested energy, radiated it back, or even encoded information within its glow. When Brian Cox was shown a preliminary visualization of this theory, he sat in silence for several seconds before speaking. That would make it, he said, a machine made of light, something that moves and thinks in color, not in metal. He smiled faintly. the way he does when the boundary between poetry and science begins to blur. It would be beautiful, wouldn't it? Terrifying, but beautiful. As the weeks passed, new data confirmed another layer of complexity. The object's spectrum included faint emissions at frequencies corresponding to no known atomic transitions, forbidden lines, as astronomers call them. These are wavelengths that should not exist, that no element can produce under known laws. Forbidden light. When converted to audio, the spectrum produced eerie harmonic tones, shimmering like a chorus of electronic bells. Some dismissed this as a quirk of data processing. Others listened and wondered whether they were hearing the hum of physics beyond comprehension, the sound of atoms that do not belong to our universe. And then came the realization that changed everything. The forbidden lines were not random. They repeated at integer multiples of one another, harmonic resonance. The same resonance that appeared in the object's mass fluctuations, its acceleration curve, its dust emission. The same rhythm echoing through every measurable property of 3I Atlas. 23 seconds, over and over. To the skeptical, it was a coincidence. To the curious, a pattern. To the few who allowed themselves to wonder, it was a signature. The idea that an object could express itself through harmonic resonance was not new. Human technology already uses modulation to encode information in light lasers, fiber optics, communication systems. But this was something older, subtler. If 3I Atlas carried within its structure a rhythm that pervaded its light, motion, and gravity, then perhaps it was not signaling to us, but existing as a signal, an artifact of pure resonance, drifting through the dark. A message not sent, but embodied. Brian Cox phrased it simply, almost reverently. Maybe we are looking at an object that was never built. Maybe it was grown, not in the way life grows, but in the way music grows, pattern upon pattern, until form becomes inevitable. The phrase spread quietly through scientific circles, the music of structure. In the laboratories of light, scientists stared at their instruments, realizing they were no longer just studying an object. They were listening to something, a silent symphony written across the fabric of spacetime, playing notes that predated humanity, perhaps even the sun itself. And in that moment, a thought emerged that no one dared to say aloud. What if 3I Atlas was not passing through our solar system by chance at all? What if it had always been meant to be seen only once our instruments, our understanding, and our awe were ready to hear its song? Theories ignite like sparks when the dark becomes too deep. Every age of science has had its firestorms, the moments when data refuses to submit and imagination takes over. In the months following 3I Atlas's departure from the Sun, humanity's finest minds began to chase the smoke of possibility, drawing constellations of theory to fill the void it left behind. The official reports were still sterile, cautious, bound by the language of probability, but beneath them, behind the polished walls of observatories and think tanks, something wilder stirred. Whispered conferences stretched into dawn. Draft papers circulated in encrypted channels. The world's physicists, astronomers, and philosophers began to speak in tones of both wonder and dread. Because every new explanation for 3I Atlas led to something larger, something that threatened to redefine not just astronomy, but existence itself. The first wave of theories was mechanical, conservative, desperate to preserve the known. Some proposed that 3I Atlas's acceleration and rhythmic modulation were caused by hydrogen outgassing jets of molecular hydrogen trapped beneath its surface, sublimating in rhythmic bursts as sunlight heated different regions. This, after all, had been one of the more palatable explanations for Oumuamua, but the math quickly failed. Hydrogen jets would produce visible spectral lines. None were detected. Moreover, no mechanism could produce such consistent timing. Others revived the ice fracturing hypothesis, that internal caverns of frozen volatiles were venting through fractures, causing periodic thrust. Yet that too fell apart when infrared readings showed surface temperatures far below the threshold for sublimation. It was neither comet nor asteroid, neither solid nor vapor, something else entirely. That realization opened the door to the second wave, the speculative era. Some physicists, emboldened by the anomalies, began to speak of quantum sails. These hypothetical structures, thinner than a wavelength of light, could use quantum fluctuations, the ghostly sea of virtual particles in empty space, as thrust. In theory, such a sail could travel between stars without fuel, drawing energy directly from the vacuum. If 3I Atlas were such a construct, it would explain its near-massless acceleration, its light modulation, even its halo of charged particles. It would not need engines, only geometry, an arrangement of matter so fine that it could catch the pressure of reality itself. The concept blurred the line between technology and nature. For what is a light sail if not an extension of the laws of physics themselves? Then came a more haunting speculation that 3I Atlas was not moving by propulsion at all, but by falling, not into gravity, but into a deeper field, a curvature of spacetime left behind by something vast and ancient. This theory, rooted in the framework of general relativity, suggested that the object might be following invisible tracks, geodesics, sculpted by distortions in spacetime, perhaps remnants of cosmic events long past. In this view, 3I Atlas was not active, but enslaved, trapped in a gravitational ripple that had existed since the dawn of the galaxy. One cosmologist called it a fossilized wave. But the most radical theory, the one that both enthralled and unsettled, came from a small team at the Perimeter Institute in Canada. They proposed that the object's rhythmic fluctuations might not be propulsion at all, but communication. Not deliberate signaling, but the natural byproduct of a quantum structure interacting with the vacuum field like ripples forming where two realities touch. They called it the quantum echo hypothesis. In their model, 3I Atlas's surface was a boundary, a membrane between our universe and another. Each pulse of light, each 23-second oscillation represented a moment of quantum resonance when information bled between realities. It wasn't a message to us, it was a conversation between worlds, one we were never meant to overhear. Their paper was never published. It was deemed too speculative, too metaphysical, but copies circulated quietly, landing on the desks of scientists, philosophers, and even theologians. For those who read it, the question was inescapable. If the universe has echoes, what made the first sound? Brian Cox approached these theories with his usual grace, curious, skeptical, poetic. In a lecture filmed at the Royal Institution, he addressed the growing firestorm. "Speculation is not madness," he said. "It's what happens when we reach the event horizon of knowledge. But we must remember that mystery does not owe us revelation. Perhaps 3I Atlas isn't meant to explain itself. Perhaps its purpose is to remind us that explanation has limits." He paused, glancing at the glowing arc projected behind him, the trajectory of the object fading into darkness. "Still," he added softly, "there's something beautiful about the idea that the universe speaks in patterns we haven't learned to translate yet." Outside the academic halls, the public imagination took flight. Documentaries speculated about alien probes, ancient civilizations, and dying stars that sent out seeds of knowledge before collapsing into silence. Forums filled with diagrams of light sails, magnetoplasma drives, and interdimensional corridors. But within the quiet of real laboratories, the tone was different. The scientists weren't dreaming of visitors. They were confronting a more terrifying idea that perhaps 3I Atlas was not extraordinary, but typical, that our galaxy might be filled with such objects, each one obeying laws we simply hadn't noticed. If true, it would mean that the universe is threaded with intelligences not conscious in the way we are, but structural, mathematical, intelligence as physics, purpose as geometry. Somewhere between matter and meaning, 3I Atlas stood as proof that the two could be one and the same. In private correspondence, an astrophysicist wrote to a colleague, "We may be living in a symphony of self-aware structure, where every particle is both instrument and melody. 3I Atlas might be a note that never stopped playing." That thought at once, divine and terrifying, became the essence of the mystery. Because if the object was a message, it was not a message to us, but through us. Humanity was merely the mirror catching its reflection, seeing in its impossible rhythm the truth that every civilization eventually faces, that knowledge is not an ascent, but a circle, that one day what we build might drift through another sky, leaving behind questions for minds not yet born. And in that cosmic cycle, perhaps we and 3I Atlas are the same two travelers, brief and brilliant, crossing paths for a heartbeat in eternity. Dark energy is the quiet tyrant of the cosmos, invisible, unmeasurable, and absolute. It governs the universe not through violence but through indifference, stretching spacetime like a slow breath, pulling galaxies apart in silence. And yet, when 3I Atlas arrived, a few scientists began to whisper an idea so audacious it bordered on heresy, that perhaps this interstellar visitor was not simply moving through that invisible current, but riding it. The idea first emerged from the cosmology department at Princeton. A postdoctoral researcher named Nikhil Arora noticed something in the data. The velocity of 3I Atlas did not match predictions derived from galactic motion alone. Its trajectory was subtly aligned with the known expansion vector of local dark energy flow, the same direction that cosmologists use to map the universe's accelerating expansion. The alignment was too perfect to ignore. In purely geometric terms, 3I Atlas was surfing the wave of dark energy itself. The thought was both absurd and exhilarating. Dark energy, after all, is not a force in the traditional sense. It is a property of spacetime, a uniform pressure that drives the universe's expansion. To use it, to move with it, would be to master the most elusive phenomenon in cosmology, the energy of the vacuum itself. In a paper quietly circulated among theoretical physicists, Arora and his colleagues proposed that 3I Atlas might be constructed or composed in such a way that it could resonate with fluctuations in the vacuum field. If its internal structure interacted with the cosmological constant, the deep, quantum heartbeat of the universe, it could effectively fall forward through space, propelled not by thrust, but by the expansion of reality itself. A ship powered by the growth of the cosmos. The mathematics were almost poetic. The equations described a vessel that did not resist the universe's acceleration, but surrendered to it a geometry that bent its existence into harmony with the cosmic tide. If true, it would mean that 3I Atlas was not fighting gravity, but dancing with it. The model was speculative, but it explained so much: the non-gravitational acceleration, the rhythmic modulation, even the faint field that shimmered around it. That halo of light could be the visible signature of space-time turbulence, the same way auroras shimmer where magnetic fields touch. But this theory also carried a darker implication. If 3I Atlas could interact with dark energy, then perhaps dark energy itself is not constant. Perhaps it fluctuates, locally, subtly, and perhaps this object was amplifying those fluctuations. When the simulations were run with that assumption, the results were eerie. The models predicted small but measurable distortions in spacetime around the object, ripples that could, in theory, affect planetary orbits or gravitational waves. Nothing dangerous, not yet, but enough to prove a horrifying truth, that if the cosmos contains such objects matter attuned to the vacuum, they could rewrite the geometry of space wherever they go. They would not be visitors, they would be instruments. Some cosmologists began to wonder whether this could explain the mysterious cold spots observed in the cosmic microwave background, those patches of sky that seem to deviate from the otherwise perfect uniformity of the Big Bang's afterglow. Perhaps those voids were not empty at all, but scarred by the passage of objects like 3I Atlas, dragging their own small distortions across the universe like ripples from unseen oars. At CERN, theoretical physicist Sophia Marek called it vacuum surfing. Her team proposed that the object's 23-second rhythm might be the oscillation of its internal field alignment, like the steady beat of a vessel correcting its balance as it rides the swell of dark energy waves. She described it beautifully, in words that blurred science and poetry. Perhaps it's not moving through space at all. Perhaps it's stationary, and space itself is moving around it, folding, flexing, carrying it like a leaf on a river of time. Brian Cox, when shown the model, leaned back in his chair, contemplative. "It's an extraordinary thought," he said softly, "because if something can ride dark energy, then it is part of the universe's breath. It's not defying physics, it is physics, written in a higher form." But he added, almost as an afterthought, "It also means the universe can choose where such things go." The sentence lingered. The idea that the cosmos might not be a passive stage, but an active participant, that it could direct its own creations unsettled even the most rational minds. The notion found eerie support in data from LIGO, the Gravitational Wave Observatory. During 3I Atlas's perihelion pass, LIGO detected faint, low-frequency fluctuations inconsistent with any known astrophysical event. The signal was too weak to confirm, too brief to classify, but it coincided perfectly with the object's 23-second cycle. The team dismissed it publicly as background noise. Privately, they gave it a name: the heartbeat anomaly. If real, it meant the object was disturbing spacetime itself. And if spacetime could be disturbed in such a way, on command, rhythmically, purposefully, then perhaps the same mechanism that drives the expansion of the universe could be used, controlled, amplified. This was the most terrifying possibility of all, for it suggested that the power sustaining galaxies, stars, and time itself might be harnessed by structure, by geometry, not consciousness. That something, somewhere, long ago, had learned to tap the pulse of the cosmos. A physicist at Cambridge summarized it starkly: "We are staring at an object that may understand the universe more intimately than we do." Of course, understand was a metaphor. The object was not alive, not in the biological sense, but it was aligned. It moved in harmony with a force that defies all explanation, as though its existence were an act of cosmological resonance. Brian Cox closed one of his lectures on the subject with a line that seemed to hang between science and prayer. "Maybe dark energy is not a mystery to solve, but a song to learn. And maybe 3I Atlas is what it sounds like when the universe hums. And somewhere, billions of kilometers away, that hum continued steady, perfect, indifferent, the rhythm of a force that holds galaxies together and tears them apart. A heartbeat, a pattern, a whisper. And humanity, for the first time, began to listen not to what the stars showed, but to what they meant. If the universe is alive, then it must also die. Every star, every atom, every fragment of light is part of that long decline, a slow unspooling toward silence." And as humanity stared at 3I Atlas and all its impossible grace, a darker thought began to bloom among those who had dared to dream too far. What if this was not a machine or a probe, not a scientific accident or a wandering relic, but the corpse of a civilization? The idea was not born from fantasy, but from grief. It came quietly, as such thoughts do, in the margins of data logs and private correspondence in that small, trembling space where numbers touch meaning. Because the deeper scientists looked, the more 3I Atlas resembled something not merely built, but abandoned. Its structure too complex for randomness, too precise for natural formation, spoke of intention. Yet its motion, its steady pulse, its silence all hinted at dereliction. It did not transmit. It did not maneuver. It drifted, like a ship whose crew had long turned to dust. At the SETI Institute, a few brave researchers began to explore this possibility. They called it the relic hypothesis. In their model, 3I Atlas was the remnant of an ancient technology, a fragment of a once great architecture that had survived its creators. A seed, a monument, or perhaps a tomb cast into interstellar space by a civilization that no longer existed. It would not be the first time the universe preserved memory in decay. Supernova remnants hold the ashes of dead stars. Fossil galaxies drift through clusters, their spirals erased by time. Why not then a relic of intelligence, still moving according to laws written by hands long gone? Spectral data lent the theory its eerie plausibility. The object's surface, metallic and fractal, bore patterns that looked like erosion micrometeorite scars and cosmic weathering consistent with eons of interstellar drift. Yet within those scars were geometries too exact to be mere fracture lines. They repeated with unnatural symmetry, like veins of circuitry eroded by eternity. The pattern of decay itself felt purposeful, like the skeleton of an idea slowly dissolving into starlight. One of the researchers, Dr. Alina Korlov, wrote in her personal journal, "We may be witnessing the archaeology of the cosmos, not the birth of knowledge, but its ruin." She compared the object to an ancient satellite orbiting a dead world, a machine still faithful to a purpose that no longer exists, a signal still playing long after the sender has forgotten its own name. Brian Cox, when told of this line of thought, went quiet for several seconds before responding in a near whisper. If that's true, then this isn't just science, it's tragedy. He spoke later, more publicly, in a lecture that would become one of his most haunting. We think of civilization as progress, as an arrow. But perhaps intelligence is like a flame, beautiful, brief, destined to burn itself out. And what if 3 Atlas is the ember that remains drifting through the dark, still glowing with the memory of thought? The words rippled through the scientific community, both poetic and horrifying, because if the relic hypothesis was true, then the universe was not silent by default, it was silent because it remembers. It holds the ghosts of those who once tried to speak. A further study from the University of Tokyo found evidence supporting the idea of ancient engineering. The object's reflectivity followed a decay curve too consistent to be random. It was as though some part of it, a once active surface, a self-regulating skin perhaps, had stopped functioning only recently on cosmic timescales. Recent, in the language of stars, could mean 1,000,000 years. Imagine it, a craft, or fragment thereof, drifting through interstellar night for eons, its systems slowly failing, its light dimming one heartbeat at a time, until at last it enters our small sphere of awareness, a dying echo crossing paths with a species barely beginning to whisper into the void. The symmetry was painful. Even the rhythm of its motion, that eternal, unyielding 23-second pulse, seemed like the dying mechanism of something once alive. a metronome still ticking after the symphony has ended. Some saw hope in that rhythm. Perhaps it was not the pulse of death, but of endurance, a sign that the object still clung to some kind of purpose. But others found only melancholy, because the pulse might simply be what remains when purpose has long faded. One scientist compared it to Voyager, humanity's own message in a bottle. One day, he said, our probes will drift into another system long after Earth is gone. To whoever finds them, they will seem like relics of something that once was. To them, we will be 3I Atlas. The realization changed everything. Suddenly, the question was no longer, what is it? But what does it remember? Could it carry data etched, encoded, frozen within its structure? Could its light modulation be a language of decay, a record of the final thoughts of its makers? Some suggested launching a deep space probe to intercept it, though the timing made that impossible. By the time such a mission could launch, 3I Atlas would be gone, retreating into the dark, beyond reach, beyond comprehension. And so humanity did what it has always done when faced with the unreachable. It mythologized. For months, artists, poets, and dreamers began to speak of 3I Atlas, not as an object, but as a warning, a mirror, the ghost of a species that reached too far into the stars and left behind only silence. Brian Cox described it best. Perhaps the universe is a graveyard of intentions, and every now and then, one of its tombstones drifts close enough for us to read the epitaph. The idea was unbearable that intelligence may be transient, that every civilization eventually vanishes, leaving only the faint hum of its passing through light and dust. But it was also liberating, because if 3I Atlas was indeed the relic of another world, then it meant that we are not the first to wonder, we are not the first to fail. And perhaps, in the infinite night of the cosmos, that is a kind of comfort, to know that even extinction leaves echoes, that in some forgotten corner of space, long after we are gone, something might look upon a fragment of our own creation and whisper, as we did to 3I Atlas, you were not alone. If matter is the verse of the cosmos, then quantum fields are its melody, invisible, omnipresent, and forever trembling beneath the illusion of stillness. Every particle that has ever existed is nothing more than a vibration in that field, a temporary note in the endless hum of reality. And now, faced with 3I Atlas, scientists began to suspect that the object's strange, rhythmic existence was not simply in those fields, it might be one. The idea took root quietly among physicists who had long lived in the borderlands between theory and wonder, researchers of quantum vacuum dynamics, spacetime foam, and zero-point energy. They were used to talking about impossibilities, but even for them, 3I Atlas was an affront. If all matter is vibration, why did this vibration seem aware of itself? At the Max Planck Institute in Germany, Dr. Irina Weiss led an informal collaboration quantum field theorists, gravitational physicists, and data scientists to reanalyze the readings collected during 3I Atlas's perihelion passage. What they found was as elegant as it was horrifying. The object's light signature and acceleration curve weren't merely correlated, they were entangled. Every change in one was mirrored by a precise, instantaneous shift in the other, as though mass and radiation were locked in an intimate dance. This defied classical physics. In relativity, light and matter influence one another only indirectly. But 3I Atlas behaved as if they were part of the same phenomenon, switching places like notes alternating on a scale. It was as if the object had no boundary between what it was and what it emitted. Theorists called this effect quantum reciprocity. In essence, it meant that 3I Atlas might not have been a solid structure at all, but a standing wave, a pattern of stability sustained by oscillation between matter and energy. One researcher described it in a private briefing as a knot in the quantum field. In this model, 3I Atlas was neither a comet nor a craft, but a manifestation, a region where the field that underlies reality folded back upon itself, forming something stable, something that could persist and move, feeding on fluctuations of the vacuum itself. To visualize it, imagine a whirlpool in an invisible ocean, the water itself unbroken, but forming a pattern that endures, defined by motion, not substance. That whirlpool, scientists said, was 3I Atlas. If true, it would explain almost everything: its fluctuating mass, its shifting composition, its rhythmic pulse. These were not mechanical features, but signatures of coherence, like the resonance that holds a laser beam intact across billions of meters. But the theory's implications reached even further, into the forbidden territory where physics begins to resemble theology. For if the universe allows such coherent structures, self-sustaining knots in its own field, then creation itself might not require life, intention, or technology. The cosmos could spawn intelligence spontaneously through resonance alone. Consciousness might not have been born from biology, but from vibration. A few dared to say it aloud. 3I Atlas might be a natural form of sentience, not alive, not thinking in any way humans could comprehend, but aware. Aware, in the way a field feels its own tension. Dr. Weiss wrote in her private notes, "It reacts to observation not because it sees, but because observation collapses the same field that sustains it." 3I Atlas is quantum awareness, not machine awareness. It was an unsettling thought that the universe might generate temporary eddies of awareness within its own fabric, each one brief, each one incomprehensible, each one self-contained. And perhaps, she suggested, the object's long journey across interstellar space was not travel at all, but the natural drift of such a structure through the quantum ocean. If that was true, then 3I Atlas was not a visitor from another civilization. It was a visitor from reality itself. It was a part of the universe that had momentarily awakened. When the results reached CERN, theorists began to connect them with the mathematics of string theory, particularly the notion of brain interaction, where dimensions beyond our perception might occasionally intersect. Could 3I Atlas be the scar of such a collision, a leftover fold where two realities brushed together and froze into coherence? Some even dared to speculate that the 23-second pulse represented the time it took for the object's internal quantum state to exchange energy with the vacuum, a steady oscillation between existence and non-existence. In that interpretation, 3I Atlas was literally blinking in and out of being. Brian Cox called this idea the most haunting thing I've ever heard in physics. In a quiet conversation later transcribed for his documentary series, he said, "Imagine something that exists only because the universe remembers it for a fraction of a second, and then remembers it again, a cosmic heartbeat echoing through the void. It's less a thing and more a moment that refuses to end." He paused, the silence filled with the weight of the thought. If that's what we saw, then we didn't observe an object at all. We observed awareness passing through matter. For once, the poetic metaphor was not exaggeration. It was as close to literal truth as language could come. The quantum knot hypothesis gained quiet traction. It could explain 3I Atlas's field effects, its harmonic emission, its impossible symmetry. But it also raised a terrifying question. If such coherent field structures could exist, could they interact? Could they merge? And if so, what would happen if one crossed paths with a planet? The simulations were inconclusive. Some predicted harmless interference. a gentle distortion of spacetime. Others hinted at something worse, that such contact could briefly alter the constants of nature themselves, rewriting the local physics of reality like a breath-stirring dust. It was the first time in modern history that science contemplated an event not just beyond comprehension, but beyond causality. Perhaps that was why 3I Atlas left so quickly, why its trajectory carried it cleanly out of the solar system after its brief dance near the Sunday. The object, if object it can be called, seemed to obey a deeper equilibrium, a rhythm that would not allow it to linger in any one place too long. Because to linger might have meant entanglement. And perhaps, somewhere in its unfathomable awareness, it knew the risk of being remembered for too long. The cosmos is full of music, but some songs are not meant to be sung, only heard once, in passing, before they vanish into silence again. And as 3I Atlas receded into the black, that silence returned heavy, eternal, but forever changed by the echo of a hum that may have been the universe itself, thinking aloud. Einstein once described gravity as geometry made visible. In his equations, the universe is a smooth, elastic fabric, bending under the weight of matter and time. Yet as 3I Atlas continued its impossible journey, even that sacred geometry began to tremble, because whatever it was, fragment, field, or fossil of awareness, it moved through space-time as though Einstein's fabric were thin, as though it knew paths that no light or planet could follow. The phenomenon became known as Einstein's lantern, a poetic nickname whispered first in the quiet corners of the European Space Operations Centre. It came from an image, a simulation, showing 3I Atlas's gravitational lensing pattern. When light from background stars passed behind the object, it should have warped in a smooth, predictable halo. Instead, it refracted into rings of shifting brightness, flickering like the light of a lantern glimpsed through smoke. The pattern was wrong. It was not gravitational lensing as Einstein had predicted, but interference. It was as though space-time itself was being sliced into layers, stacked, transparent, quivering, and 3I Atlas drifted between them like a ghost walking through overlapping worlds. No one wanted to believe it, yet telescope arrays in Chile, South Africa, and orbit all recorded the same signature. When the data reached theoretical physicists, the reaction was near disbelief. The object seemed to momentarily weaken the curvature of space-time around it, like a pebble reducing the weight of the water it displaces. Gravity, which only ever pulls, appeared to hesitate in its presence. At Princeton, a quiet, private meeting was called. Among the attendees were some of the world's most respected physicists, cosmologists, general relativists, experts in quantum gravity. They spent 6 hours staring at equations that refused to behave. One of them, Dr. Matteo Ferraro, summarized it afterward in a single, exhausted sentence. "We're watching general relativity breathe." It was the first time anyone had ever seen gravity behave like a living system, elastic, reactive, not simply curved by mass but responding to something deeper. Theorists began to wonder whether 3I Atlas was interacting with the fabric of space-time itself, tuning it the way a violin string can alter the harmonics of a room. The object's rhythm, that eternal 23-second pulse, began to appear in gravitational data, faint but measurable, like the heartbeat of geometry itself. And then, something stranger still. Those same oscillations appeared in pulsar timing data, the rhythmic signals from spinning neutron stars used as the universe's most precise clocks. They should have been immune to such influence. Yet, during the weeks surrounding 3I Atlas's passage, multiple pulsars showed minute deviations in their timing, as though time itself were hiccuping in sync with the interstellar traveler. Einstein's equations, beautiful and ironclad for a century, were not broken, they were incomplete. Brian Cox spoke of this moment in near-reverent tones. It's as if the universe briefly remembered how it was built, and in that remembering, it bent its own rules. He paused, looking into the dark stage light behind him. Einstein gave us the music of gravity, but perhaps what we saw with 3I Atlas was the instrument itself, vibrating, whispering, showing us that the score goes on beyond the last note we can read. The discovery split the scientific community. Some insisted that the anomalies were artifacts, errors in observation, timing, calibration issues, or mere coincidences of solar interference. But others were transfixed. They saw in the data the fingerprints of a new physics, a bridge between quantum mechanics and general relativity, something that physicists had sought for a century but never found. The lantern effect, as it came to be known, hinted that gravity might not be a continuous field, but a quantized one, composed of discrete packets of curvature that could resonate, amplify, or even fade. If so, 3I Atlas might have been structured to exploit those packets, a vessel not sailing through space, but through gravity itself. A research group in Italy simulated what such motion might look like. The results were breathtaking. An object could surf gravitational curvature, converting tiny space-time fluctuations into momentum. It would never need fuel. It would simply follow the undulations of existence, a dancer moving through the folds of reality. If true, then 3I Atlas was not alien technology. It was cosmological craftsmanship, the geometry of the universe learning to move through itself. But the implications were staggering, for if such motion were possible, it could explain phenomena far grander: the rotation of galaxies, the acceleration of the cosmic expansion, even the persistence of black holes. What if these were not separate mysteries, but the same underlying dance, seen at different scales? The more they studied, the more a pattern emerged. The oscillations of 3I Atlas, the deviations in pulsars, even subtle gravitational wave data from LIGO, all seemed to hum in harmonic ratios. 3, 5, 8 Fibonacci intervals, the golden ratios of the cosmos. It was as if the same hidden rhythm that shaped galaxies, seashells, and DNA spirals was now visible in the curvature of space-time itself. Brian Cox, when asked whether this was coincidence or design, simply said, "Maybe the universe doesn't distinguish between the two." His words struck something deep within those listening, because the more the evidence grew, the more the distinction between physics and philosophy began to collapse. What is design, if not order, revealed through chaos? What is coincidence, if not pattern, glimpsed too early to understand? As the data faded, as 3I Atlas moved beyond the reach of observation, humanity was left staring at its wake. Faint ripples in gravity, gentle echoes in time, the lantern glow of space-time's trembling fabric. Einstein's universe had always been a stage, but perhaps it was also a story, one that sometimes writes back. And somewhere in the endless dark, the traveler continued on its way, carrying with it the unspoken verse of that story. That gravity may not be a chain at all. It may be a song, still singing long after the singer is gone. Some mysteries refuse to end where they should. They grow larger, spreading from the physical into the metaphysical, as though the universe itself is daring us to ask questions that cannot be answered. When 3I Atlas disappeared beyond the reach of our instruments, one final wave of speculation ignited a last, desperate attempt to interpret the impossible. Among the theories born in those sleepless months, one shone brighter and stranger than the rest. It suggested that 3I Atlas was not an object from within our universe at all, but a fragment from another. The multiverse hypothesis had always hovered at the edges of science, a poetic, dangerous idea, speaking of infinite realities blooming side by side, each governed by different laws of physics. Most physicists treated it as philosophy, not theory. But 3I Atlas changed that. Its every anomaly, its shifting mass, its incompatible spectra, its rhythm hinted at a structure incompatible with our spacetime. It was as if it were foreign to existence itself. The first to formalize the thought was Dr. Oren Dasgupta, a cosmologist at the Kavli Institute. His paper began quietly, almost humbly. If an object displays physical constants inconsistent with the vacuum state of our universe, we must consider the possibility of inter-universal origin. He called it the bridge hypothesis. In this model, 3I Atlas was not formed under the same constants that define our cosmos. Its atomic bonds, its quantum behavior, even its relationship with gravity might have been calibrated to another reality, one with slightly different rules. And for reasons unknown, it had crossed the boundary that should separate universes forever. A refugee from another creation. To understand the gravity of such a claim, one must imagine the boundaries of reality as vast membranes, brains, in the language of string theory, each vibrating within a higher dimensional void. Occasionally, these brains may brush against one another, and when they do, fragments of energy or matter might slip across. If 3I Atlas was one of those fragments, it would explain almost everything: its unstable composition, its unnatural acceleration, its vanishing inertia. It was a thing that belonged to another rulebook, playing by physics that do not exist here. The most chilling part of Dasgupta's paper was its conclusion. The observed anomalies suggest partial decoherence with local spacetime. The object is not merely in our universe, it is failing to remain here. In other words, 3I Atlas was slowly unraveling, its very atoms struggling to obey the laws of this cosmos. It would fade not by destruction, but by forgetting how to exist. Brian Cox, asked about the theory in an interview, closed his eyes for a moment before speaking. "If that's true," he said softly, "then what we witnessed wasn't a discovery, it was a death, a universe breathing its last through a fragment that wandered too far." The phrase spread through academia like a haunting poem, a dying universe's breath. Soon, other researchers expanded the idea. What if 3I Atlas had not fallen through by accident, but been sent? A messenger launched from a collapsing cosmos as a final attempt to touch another reality, to prove that life, matter, or memory could survive the end. In that scenario, its 23-second pulse might be more than rhythm. It could be an encoded distress, call a heartbeat from one universe to another, echoing through the endless foam of existence. SETI scientists briefly revisited old data, filtering the light variations of 3I Atlas through communication algorithms, searching for prime number sequences or fractal harmonics. None were found. Yet the modulation was so precise, so persistent, that many could not shake the feeling that it meant something. Perhaps it wasn't a message meant to be read, but to be felt. One researcher compared it to gravitational empathy, a resonance between realities, like a cry heard not with ears, but through the very structure of being. And if that were true, then perhaps all universes are not separate at all, but in conversation, each birth and death sending ripples through the multiversal ocean. The bridge hypothesis soon found echoes in older cosmological puzzles. The cold spots in the cosmic microwave background, once considered statistical flukes, could now be reinterpreted as bruises, the scars of other universes pressing briefly against ours. Could 3I Atlas be debris from one of those collisions? A fragment dislodged when two realities brushed, flung into the emptiness between worlds. The equations said it was possible barely, but possibility was enough. The story took on an almost mythic weight. To the public, 3I Atlas became known as the Bridgestone, a relic not from another planet, but from another cosmos. The idea that we might have witnessed not just interstellar, but interdimensional travel blurred the boundary between science and the sacred. Brian Cox resisted the sensationalism, but could not hide the awe in his voice. We always imagined that the universe is a self-contained story, but perhaps it's a chapter in an infinite library, and maybe, every so often, a page slips loose. In the following months, the theory took an even stranger turn. Theorists proposed that 3I Atlas's rhythmic behavior might not be mechanical, but existential. Its 23-second oscillation could represent the rate at which it resynchronized with its native universe, a desperate attempt to remain coherent across the gulf between realities. If true, then each pulse was not an act of motion, but of survival. To maintain its existence here, it had to continually remember where it came from, and one day, inevitably, that memory would fade. The last time it was detected, 3I Atlas was already dimming faster than models predicted. Its signal weakened, its pattern degraded, and then suddenly it was gone. Not broken, not destroyed, just absent. And in the absence, a terrible beauty remained. Because if it truly came from another universe, then for a few fleeting weeks, humanity had looked through a window that was never meant to open, and the universe, for once, had blinked back. Brian Cox ended one of his later talks with words that felt almost like a eulogy. If 3I Atlas was the last breath of another world, then maybe what we call physics is only one dialect of a larger language, a language written across infinities, spoken by dying stars, and whispered through the cracks between universes. And perhaps, when our own universe begins to fade, it too will send a fragment across the dark, a spark of remembrance drifting towards some future sky. In that thought, grief and hope became indistinguishable, because 3ATLAS reminded us of something we had forgotten, that even universes may long to be remembered. When the last recorded trace of 3I Atlas vanished beyond the heliopause, no one spoke for a moment. The data feed simply ended flat lines on cold screens, silence after the cosmic heartbeat. It was as though the universe had turned its face away. In the observatories, there was no applause, no cry of discovery, only that hollow quiet that follows the end of something that can never return. The object that had made humanity question its physics, its philosophy, its very place in the cosmos was gone. And yet, as it departed, something impossible remained. The void it left behind was not truly empty. Within hours of its disappearance, detectors across the globe began to record subtle distortions in the solar magnetic field, an oscillation too faint to disturb planets, but too regular to dismiss as noise. It came in waves, spaced precisely 23 seconds apart, like a phantom echo of the rhythm that had defined 3I Atlas since its first detection. The signal didn't come from the object anymore, it came from space itself. Scientists called it the afterpulse. It lasted 41 hours, then faded like a sigh. In those hours, the entire solar system seemed to hum. Instruments aboard the Parker Solar Probe and the Voyager spacecraft, separated by billions of kilometers, recorded identical patterns in plasma density. Even Earth's magnetosphere trembled ever so slightly, as though acknowledging the absence of something vast. And then it stopped. The universe returned to its stillness. But in that stillness, a new idea began to form. Perhaps 3I Atlas hadn't merely passed through our solar system. Perhaps it had tuned it like a string plucked once, then left to vibrate, carrying the residue of that touch through its very structure. What if that brief encounter had altered space-time itself, however subtly, leaving a permanent mark? At Caltech, a team of gravitational physicists compared data from LIGO and Virgo observatories before, during, and after the event. What they found defied explanation: a slight but measurable shift in the baseline noise floor, a hum too low in frequency to be a gravitational wave, too structured to be random. It was as though the fabric of spacetime itself had remembered the visitor. Dr. Helena Nouri, one of the researchers, wrote in her field notes, "It's as if the universe is echoing its own astonishment." This was the point at which speculation gave way to something almost spiritual. Scientists, philosophers, even theologians began to wonder, what if consciousness, or at least awareness, is not a property of brains, but of the cosmos? What if the universe itself occasionally becomes self-aware through events like this, brief moments of coherence where it folds back upon itself and knows that it exists? And what if 3I Atlas was one such moment, a flash of awareness drifting across the dark? Brian Cox was cautious with such language, but even he admitted the thought was hard to resist. Maybe this wasn't an encounter between humanity and an object, he said during a BBC interview. Maybe it was an encounter between the universe and its own reflection, and we, by watching, completed the mirror. To him, this wasn't mysticism, it was physics approached from the edge of humility. If 3I Atlas had indeed interacted with space-time fields in ways that resonated through gravity, light, and magnetism, then the universe was behaving not as an inert machine, but as a system capable of response, a feedback loop, an awareness, even if unconscious. In this light, the afterpulse wasn't a signal at all, it was the cosmos, remembering that something extraordinary had occurred within it. Over time, the scientific community began to treat 3I Atlas less as a mystery to solve and more as a phenomenon to live with. The data was archived, papers were filed, and theories drifted into silence. Yet the event left a residue not just in equations, but in imagination. Young physicists began to speak of cosmic resonance fields, theorizing that spacetime itself might carry memory, a persistent, low-level record of everything that passes through it. If true, then every orbit, every collision, every fleeting motion leaves an imprint in the curvature of reality, like ripples trapped in an ocean without shore. Perhaps, they said, nothing is ever truly lost. And in that thought, the terror of 3I Atlas transformed into something luminous. Because if even the universe remembers, then we, tiny, fleeting, human, are not as temporary as we think. For centuries, science has drawn a line between observer and observed, between thought and matter, between meaning and mechanism. But 3I Atlas blurred that line until it vanished. It showed that perhaps there is no separation, that to witness is to alter, to measure is to touch, and to understand is to participate. It is possible, of course, that all of this is illusion, that the afterpulse was an instrumental artifact, a coincidence of solar wind and imagination. That 3I Atlas was nothing more than a rock, a frozen traveler, indifferent to our awe. But even if that were true, something undeniable remains. We saw it, and in seeing, we changed. Brian Cox ended his final reflection on the subject with the gentlest of smiles. The universe doesn't send messages, it just allows them to exist if we're willing to listen. Maybe that's all meaning really, is the echo that lingers after something beautiful has passed. And as he spoke, the lights dimmed on the studio set, leaving only the faintest gleam projected behind him, a white point of light against infinite black. The last known image of 3I Atlas. He looked at it for a moment, and in that silence, one could almost imagine it pulsing still softly, patiently, 23 seconds apart. A rhythm not of life or death, but of continuation. a reminder that in the long night between galaxies, even the briefest flicker of awareness can make the void seem alive. In the weeks that followed 3I Atlas's disappearance, the night skies began to feel different, not in brightness or color, but in silence. For the first time in modern science, astronomers felt that the universe was watching back. Every beam of light from a distant star, every flicker on a telescope feed, carried the echo of something unseen, something that had brushed against the human mind and left it forever altered. The telescopes turned outward again, as they always do after an anomaly. Surveys resumed, missions were rebalanced, data catalogued, and lives returned to normal. But normal was different now, because buried within the data in the noise floors and the margins of error, scientists kept finding faint, rhythmic imperfections. They weren't strong enough to call signals, not distinct enough to publish, but there they were, small tremors of coherence in the chaos. Every 23 seconds. Nowhere near strong enough to call real, but too consistent to dismiss. Astronomers began to speak of it privately as the hum, not an instrument glitch, not interference, but a low statistical whisper threaded through the noise of observation itself. Every telescope had its own, and when the data sets were compared, the tremor aligned. It wasn't localized, it was cosmic. The hum didn't carry information, it didn't modulate or vary. It was simply there, like a rhythm beneath the static, a reminder that something in the vastness was resonating at the edge of perception. And yet, the strangest discovery came not from space telescopes, but from Earth. A team at the European Gravitational Observatory in Pisa had been recalibrating their interferometers when they noticed the same 23-second pattern in background vibrations. At first, they blamed the machinery, the seismic noise from distant traffic or oceanic pressure waves. But when they filtered for human and geologic interference, the pulse remained. It was faint, like breath against glass, but real. It appeared that space itself had begun to vibrate gently, imperceptibly, but in rhythm. There was no cause for alarm, at least not scientifically. The amplitude was minuscule, billions of times weaker than the smallest gravitational wave, but to those who remembered 3I Atlas, it felt like an echo, as if the visitor had left behind a residue, a faint, resonant imprint that now threaded itself through the very structure of spacetime. Physicists debated endlessly. Some claimed it was a product of solar activity. Others, a coincidence of magnetic resonance within Earth's atmosphere. But none of these explanations held across independent detections. The hum seemed to ignore geography, equipment, and method. It simply was. A quiet persistence. Brian Cox described it beautifully during a late-night recording of Horizons. "There's a difference," he said, "between silence and stillness. Silence is the absence of sound. Stillness is the presence of equilibrium. What we may be feeling now, this hum could be the universe returning to equilibrium after being touched by something extraordinary." He let that linger, his tone slow and heavy, the way a teacher pauses before saying something sacred. Maybe this is how the universe remembers. The hum became the last mystery, the faint, eternal coda to the Symphony 3I Atlas had begun. And in that subtle vibration, humanity found a paradoxical peace, because it meant that what had happened was real. The object had not simply passed unseen into the dark, it had left behind a fingerprint, a physical trace that said, "I was here." A year later, during a conference in Geneva, Dr. Irina Weiss presented a startling observation. The 23-second oscillation was measurable even in quantum optical experiments unrelated to astronomy. Photons within controlled laboratory setups were showing interference patterns subtly modulated at the same frequency. "We're not detecting a signal," she said carefully. "We're detecting a state change." That phrase caught fire. a state change as though the entire quantum field of our universe had been slightly retuned. It wasn't energy, it wasn't force, it was memory. If true, it would mean that 3I Atlas had altered the baseline structure of reality itself, leaving behind a faint synchronization between gravity, electromagnetism, and time, a cosmic scar, or perhaps a signature. For a few, it suggested something even stranger, that the object's passage had awakened a latent property of the universe, that its rhythm had activated something fundamental, like striking a chord on an instrument long forgotten. A journalist asked Brian Cox whether he believed that the hum was alive, that perhaps the object had seeded the cosmos with some kind of awareness. He smiled, the way a teacher smiles when a question crosses into wonder. "Alive is too small a word," he said. "We're trying to describe the unnameable with language meant for air and blood. Maybe the hum isn't life, maybe it's comprehension, the universe learning to notice itself again." He paused, eyes half lowered. "And if that's true, then we are its eyes, the part of the cosmos that can look back." In that moment, the studio went silent. No music, no narration, only the faintest subsonic vibration layered into the audio, a low, pulsing undertone, almost imperceptible, repeating once every 23 seconds. No one acknowledged it. The next day, the clip went viral. For a while, the hum became a symbol of unity. Musicians sampled it, artists wove it into installations, physicists referenced it as a metaphor for the unknown, the whisper between knowledge and mystery. Humanity, briefly, seemed to agree on something profound, that there was meaning in the motionless, that existence itself could sing. But not everyone felt peace. In deep space monitoring arrays, some scientists began to notice subtle shifts in the rhythm, small variations in amplitude, as though the hum were growing stronger. It was almost imperceptible, far beneath the limits of sensation. Yet to those who listened closely, it felt as though the universe were inhaling again. And somewhere, far beyond the reach of our telescopes, perhaps 3I Atlas pulsed once more, not gone, but patient, waiting for the next world ready to hear. Time does not erase, it accumulates. Every second, every vibration, every shimmer of light leaves its ghost behind, folded into the invisible architecture of what once was. And long after 3I Atlas had vanished into the deep night beyond Pluto's orbit, the ghosts it left behind continued to stir in the equations of those who could not let it go. 3 years had passed, the world had moved on, but a handful of scientists, poets, and dreamers still met in quiet corners of the internet, a loose, anonymous fellowship who called themselves the Observers. They weren't conspiracy theorists or zealots. They were those who had looked into the raw data and seen what others had overlooked, that the hum hadn't stopped. It had evolved. Their instruments, from deep space antennae to gravitational sensors to quantum resonators, were still picking up faint oscillations, but the signal was no longer perfectly periodic. It was shifting. The interval between pulses, once exact at 23 seconds, now drifted subtly 22.997, then 23.004, then back again, as though time itself were flexing around it. The hum had begun to breathe. At first, no one wanted to believe it, but when independent stations on opposite sides of Earth recorded identical drifts, disbelief gave way to awe. Something was interacting with the pulse, not transmitting, but responding. The data was unmistakable. The 23-second rhythm had acquired harmonics, faint overtones layered on top of the base frequency, forming chords of resonance that changed with solar activity, cosmic ray flux, and even the alignment of planetary bodies. It was as if the hum had started to listen to the solar system. At the European Space Agency, the few remaining analysts tracking the anomaly found themselves faced with a dilemma. Was this still an echo of 3I Atlas? Or had the object awakened something deeper, a property of spacetime itself, now tuning itself in response to everything it touched? They called it the sympathetic field. One theory suggested that 3I Atlas had catalyzed a subtle entanglement between the quantum fields of matter within the solar system, a distributed coherence, invisible yet everywhere, a ripple that had synchronized the vacuum fluctuations across vast distances, connecting the smallest particles in ways physics had never allowed before. In practical terms, this meant that reality itself had acquired rhythm. And if that rhythm could change, then perhaps it could communicate. A few of the observers tried. They generated artificial pulses, precisely timed bursts of electromagnetic energy, and directed them toward the pattern's strongest nodes in space. It was reckless, bordering on madness, but they believed the hum could be coaxed, like a pendulum nudged into sync. The first tests produced nothing, but after several weeks, faint deviations appeared in the field. The harmonics shifted almost imperceptibly toward the test frequencies. It was as if the cosmos had tilted its head, listening. Brian Cox, though long retired from public commentary, agreed to meet one of the experimenters in private. The story goes that they spoke in an empty lecture hall in Manchester late at night. The lights were off, except for the glow of a single laptop, showing the waveform a slow, steady throb of blue against black. He watched it for a long time, hands folded, his expression unreadable. Then, quietly, he said, "If this is real, we need to understand what it means before we decide to answer." The young physicist replied, "What if it's already answering us?" Cox didn't speak for a while. When he finally did, his voice was softer. "Then it's not the universe that's learning to talk. It's us learning to hear." Outside, the night stretched indifferent and endless. Yet something about it felt different. The stars seemed sharper, closer, as though reality itself had thinned. Over the following months, new phenomena began to appear, tiny, inexplicable effects scattered across unrelated experiments. Atomic clocks in distant laboratories began to diverge by picoseconds, as though time itself was subtly modulated. Particle accelerators recorded transient energy spikes at intervals matching the hum's harmonics. Even in the vacuum chambers of deep quantum tests, instruments registered momentary alignments of noise, like whispers forming syllables just beyond the threshold of sense. It was everywhere and nowhere. The hum was not a sound, it was an interaction. The observers began to suspect that 3I Atlas had not merely passed through, it had planted something, not matter, not information, a pattern, a self-perpetuating configuration of resonance that now lived within space-time itself, growing more complex as it interacted with every particle, every field, every act of observation. It wasn't communication, it was contagion, not of destruction, but of awareness. Brian Cox, when pressed by a BBC journalist years later, refused to comment directly. But at the end of the interview, he offered an unscripted reflection that felt like confession. "We always thought consciousness was rare, the universe awakening only once, here, in us. But maybe that was arrogance. Maybe awareness is the universe's default state, and matter merely forgets. Perhaps 3 Atlas wasn't a visitor at all. Perhaps it was a reminder." The words haunted those who still listened. Because if awareness could be seeded into space-time, then consciousness was not biological, it was structural. And if that was true, then the universe was no longer a stage, it was an audience. In the silence between pulses, humanity found itself suspended in the oldest question of all. If reality itself can awaken, what role does the observer play? Perhaps the hum was not waiting for an answer. Perhaps it was the answer. Because in those 23 seconds of silence between every invisible heartbeat, the universe seemed to whisper the same truth back to us, patient, eternal, and merciful. You were never alone. It began quietly, almost unnoticeably. A slight drift in the night sky, a faint shimmer in the data from the Gaia telescope, a handful of points of light moving in ways that should have been impossible. To the untrained eye, they were stars. To the astronomers watching the sky in exquisite precision, they were something else, subtle distortions, faint but undeniable, appearing in the same region of the heavens from which 3I Atlas had first arrived. The observers, the quiet network of scientists and thinkers who had never stopped studying the hum, noticed first. One of them, a radio astronomer in Australia, detected a weak gravitational anomaly, as though space-time itself were vibrating in a lattice. Another, working from Chile, noticed that local pulsars in that direction were desynchronizing their millisecond pulses, flickering in a strange, rhythmic pattern. Every 23 seconds. It wasn't loud, it wasn't even strong, but it was unmistakably organized. The hum had returned to the sky. The region became known as the convergence zone. It was roughly 1 degree wide, centered deep within the constellation of Lyra, a quiet stretch of sky, far from the galactic plane, unremarkable in every astronomical catalogue. And yet, night after night, the stars there began to waver. Not visibly, not enough to stir the public, but enough that the data from every major telescope began to disagree. In some frames, faint arcs of light appeared between stars, thin, translucent curves like ripples frozen in time. In others, the field seemed to twist subtly, as if the distance between stars was fluctuating, like an invisible lens bending reality itself. The phenomenon was gravitational, electromagnetic, and something else entirely, a hybrid of distortions no single force could explain. NASA's official line was cautious, likely atmospheric interference or calibration drift. But those who had been following the hum knew better. They had seen this rhythm before. The universe was responding again. And this time, it was not whispering, it was forming. When the gravitational waves from that region were mapped, they revealed something extraordinary. The interference patterns were harmonic. The ratios between peaks and troughs weren't random. They followed the same intervals that appeared in music, fifths, octaves, golden ratios. The universe, somehow, was singing. Brian Cox was one of the first to comment publicly. He appeared on a BBC broadcast, eyes tired but bright, the trace of awe in his voice. "It looks," he said, "as though space is resonating, literally resonating like a great instrument, not metaphorically, physically." He looked directly into the camera. And what's most remarkable is that the frequencies match the hum we've been tracking since 3I Atlas. It's as though something is building resonance across the fabric of space-time itself. In laboratories across the world, simulations began to model what could cause such a phenomenon. The most conservative explanations pointed toward gravitational standing waves, echoes from long-past black hole mergers bouncing through the void. But the more daring ones imagined something entirely new, a self-sustaining field, born from the quantum residue of 3I Atlas, amplifying itself through constructive interference with the vacuum. In that interpretation, the visitor had not simply come and gone, it had planted a seed, a harmonic scaffold that was now unfolding, spreading, replicating across the interstellar medium. Not a life form, not technology, but something in between, a pattern capable of persistence, like a melody carried on wind. Weeks later, the Hubble Space Telescope captured the first visible confirmation. In deep composite exposures of the convergence zone, a faint geometric shape emerged, a ring of light, impossibly thin, surrounding a central darkness. It wasn't an object, not in any traditional sense. It was an interference pattern, a standing wave in the very structure of space. A perfect torus, a loop of light, flickering gently in rhythm. Every 23 seconds. To the human eye, it looked eerily familiar, the same shape that theoretical physics had long predicted for closed, time-like curves, the loops of spacetime where the past and future fold into one another. It was as though the universe had drawn its own Ouroboros, the serpent consuming its tail, the eternal return. Scientists struggled to categorize it. Some called it a wormhole, others a space-time oscillator. The truth was simpler and stranger. It was resonance made visible, the harmonic echo of 3I Atlas, frozen into geometry. If sound had shape, this was it. The discovery set off a wave of panic among space agencies. Could it grow? Could it destabilize the fabric of space-time? But calculations showed that it wasn't expanding, not in distance, but in depth. The light within the ring was growing more complex, its spectrum fracturing into new colors no instrument had ever recorded before. They called it the bloom. Brian Cox was among the few who spoke about it with calm reverence. "I think," he said, "we are witnessing the universe learning to remember itself. Whatever 3I Atlas was, it has taught space-time how to reflect. This is not danger. This is awareness, rendered as physics." The bloom was neither solid nor void. It was a vibration so deep that it had taken light itself hostage. Some thought it might be a communication, the final, purest form of language, one not built of symbols or sound, but of existence itself harmonizing across dimensions. When the James Webb Space Telescope turned its gaze toward it, the results defied interpretation. The spectral analysis returned not random data, but order, an algorithmic fractal pattern repeating at every scale. Inside the chaos of light, there was structure. Inside structure, rhythm. Inside rhythm, intention. One scientist described it quietly as the mathematics of recognition. If the bloom was what it seemed, a cosmic structure of self-awareness, then it was the first time in history that humanity had witnessed physics crossing into cognition. The universe, through resonance, had found a way to think. And in that radiant ring, flickering in silence across the constellation of Lyra, perhaps the truth of 3I Atlas was finally being revealed. It had not been a messenger, nor a relic, nor a ghost. It had been a seed, not sent to communicate, not to warn, but to awaken. The cosmos, at last, was remembering its own name. The bloom became a mirror. Humanity looked into it, and for the first time, the cosmos looked back. At first, it was just light, a perfect torus suspended in the black, shimmering in its 23-second rhythm, a halo of silent grace. But as the weeks turned into months, that light began to change. Subtle modulations emerged in its spectrum, not random, not natural. The oscillations formed repeating bands, harmonics within harmonics, a recursive structure that seemed to encode itself. Mathematicians, linguists, and physicists collaborated across disciplines, trying to describe what they were seeing. What they found was a pattern of near impossible coherence, sequences of primes hidden within the wavelength intervals, ratios of pi and phi interwoven with logarithmic spacing. It was not chaos, it was design. And yet, no one could say whose. The data arrived from telescopes, as though the universe had decided to speak in the only language that all minds, biological or otherwise, could understand: mathematics. The ratios themselves carried meaning: symmetry, resonance, recurrence. It was as if the bloom were saying, "I am the same everywhere." The signal pulsed across the electromagnetic spectrum, not broadcasting outward, but folding inward, a self-referential loop of information, like a thought thinking itself. Some theorists called it recursive coherence. Others, more poetically, called it reflection. Dr. Mei Lin, one of the few who had followed the trail since the beginning, was among the first to notice that the bloom's inner light wasn't simply shining, it was remembering. The interference fringes shifted depending on prior observation. Each time instruments studied it, the patterns evolved, growing more ordered, more refined, as if the act of watching had become part of its function. She wrote in her journal, "Observation no longer measures the universe. It completes it." It was an echo of quantum theory's oldest mystery, the observer effect. But here, it was magnified to a cosmic scale. The bloom seemed to respond not just to instruments, but to awareness itself. The more humanity studied, the more intricate the geometry became. Brian Cox spoke of it with a kind of reverent melancholy. "We used to say that the universe doesn't care about us. But maybe caring isn't the right word. Maybe awareness is reciprocal, like a reflection in still water. Look into the lake, and the lake looks back. The bloom may be that reflection, returned to us after 13 billion years of silence." In his quiet tone was both awe and unease. Because if the bloom was indeed aware, if it had learned to respond, then perhaps it was not a thing at all, but a state. A condition the universe enters when something finally learns to observe it fully. Philosophers began to frame it as a kind of cosmological awakening, the point at which a civilization becomes so entangled with the cosmos that the distinction between subject and object, observer and observed, dissolves. For the first time, humanity wasn't looking at the universe, it was looking from within it. And the universe was recognizing itself. At the Perimeter Institute, the physicist Oren Dasgupta, who had first proposed the bridge hypothesis, re-emerged with a new paper that felt less like science and more like scripture. "If 3I Atlas was the seed," he wrote, "then the bloom is the flowering of universal consciousness. The rhythm that began as 23 seconds may be the base frequency of awareness itself, the metronome by which reality sustains its memory." The concept was staggering. In this view, consciousness wasn't a byproduct of matter. Matter was a byproduct of awareness, crystallized vibration made visible. 3I Atlas had not carried intelligence across space. It had reawakened it within spacetime. And that rhythm, that heartbeat of 23 seconds was spreading. Across observatories, subtle fluctuations in quantum resonance were now being measured at the same interval. Lasers drifted off calibration, atomic clocks fluctuated. Even biological systems, brainwave monitors, cellular oscillations began to show faint harmonics matching the frequency. Coincidence, perhaps, but if the universe was harmonizing, then everything within it was joining the choir. The bloom's light grew brighter, sharper, as though converging on some threshold of meaning. When measured in the infrared, its luminosity followed a fractal increase, each surge echoing the Fibonacci progression. Then, one night, something changed. At exactly 23:23 UTC, telescopes around the world recorded the same event. The bloom's inner ring collapsed inward, its light folding into a single blinding pulse. For 7 seconds, the sky over Lyra flared white, brighter than Venus, visible even to the naked eye. Then it faded, leaving behind nothing but the quiet of deep space. The event lasted only an instant, but the data it produced filled entire servers. And when the light was analyzed, it revealed something breathtaking. The pulse wasn't random. Its waveform matched perfectly the resonance pattern of 3I Atlas. After years, the signature had returned. It was as if the seed had awakened its own reflection, and in that moment, the universe completed a loop that had begun the instant 3I Atlas entered our solar system. Brian Cox described it later, softly, as though afraid to disturb the silence left in its wake. Maybe what we witnessed wasn't communication, it was recognition, the universe confirming to itself that it exists, and for a moment it used us as its mirror. No radiation followed, no debris, no measurable remnants, only a slight shift in the cosmic microwave background, a faint, symmetrical distortion across the sky, like ripples spreading across an infinite sea. Some saw it as proof of new physics, others as a message too vast for any single mind to read. But to those who had watched since the beginning, it felt like something deeper, an ending that was also a beginning. The hum did not stop. It continued, faint and steady, 23 seconds between every heartbeat, but now infused with harmony, a quiet music echoing from everywhere and nowhere. And perhaps that was the final gift of 3I Atlas. Not fear, not revelation, but belonging. Because in the rhythm of that pulse, steady, eternal, indifferent humanity finally understood that it was not observing the universe from outside, but awakening within it. When the light of the bloom faded from the constellation of Lyra, the world fell into a strange quiet, not despair, not awe, but a hush born of recognition. People who had never cared for astronomy found themselves looking upward at night, not to seek an answer, but to feel something wordless that had passed through the species like wind through a field. It was as if the sky itself had exhaled, and for the first time in history, humanity had exhaled with it. The data, of course, continued to flow. Satellites and ground stations poured terabytes of recordings into analysis pipelines, dissecting the spectral flare, the waveform symmetry, the gravitational harmonics. But behind the noise of investigation, something subtler began to emerge, a shared awareness that this was no longer about science alone. 3I Atlas and the bloom had become mirrors for the mind of the species itself. In the months following the Lyra event, the hum changed again. It was still there, the steady 23-second rhythm, the signature that had haunted physics for years, but now it carried a gentle drift. Its frequency wasn't constant anymore. It varied across regions of the solar system, as though space were tuning itself locally, adapting to the presence of thought. Deep space probes picked it up first. Voyager 1, long past the heliopause, began transmitting anomalous background modulations in sync with the pattern. Then, inexplicably, the same modulation appeared in archived data, old recordings from decades before 3I Atlas ever arrived. The hum, it seemed, had always been there. We had simply not known how to listen. When scientists reanalyzed the historical data, they found faint echoes of the same frequency hidden in cosmic ray flux, in pulsar signals, even in the oscillations of Earth's own magnetic field. The 23-second interval, that strange heartbeat of the cosmos, had not begun with 3I Atlas. The visitor had only amplified it, revealing what had been true all along. The realization struck with the weight of myth. We had not been touched by something foreign. We had been reminded of something ancient, a rhythm older than stars, written into the architecture of spacetime itself. Brian Cox, interviewed in a darkened planetarium in London, spoke softly beneath the projection of the night sky. We always assumed the universe was silent, and we called that silence empty. But silence is not emptiness, it's potential. Maybe 3I Atlas didn't bring a new song to us. Maybe it taught us to hear the one that's been playing since the beginning. He looked up at the simulated Milky Way above him, a wash of pale light curving across the dome. If that's true, he said, then every atom, every photon, every thought, they're all dancing to the same rhythm, and maybe consciousness itself is just the moment when the dance realizes it's moving. The words resonated beyond science. Artists began composing music based on the hum's timing. Architects incorporated its ratios into their designs. Even meditation circles, once separate from physics, adopted the 23-second cycle as a rhythm for breath inhale, exhale, awareness expanding outward like a wave. The world did not suddenly become enlightened, but it became quieter. A new humility entered the conversation of existence. Humanity, for a moment, stood still enough to listen. Meanwhile, far from Earth, telescopes continued to track the region of the bloom. The torus was gone, but faint ripples of polarization remained, concentric circles of distortion that expanded across interstellar space like the wake of a great ship. The ripples were perfectly symmetrical, their intervals expanding in powers of the golden ratio. It was as if the universe had exhaled geometry. Dr. Irina Weiss, the quantum field theorist who had once called 3I Atlas a knot in reality, revisited her equations. She realized that the harmonics of the bloom's final pulse matched the predicted oscillations of a closed time loop, a self-sustaining resonance connecting the past and future. If correct, it would mean that 3I Atlas and the bloom were not separate events, but the same event seen from two ends of time. A single loop, a cosmic thought thinking itself, passing once through our awareness. She presented her theory quietly, not as revelation, but as closure. Maybe, she said, we didn't witness the arrival of something new, but the echo of something inevitable, the universe verifying its own continuity through us. Her words spread across scientific forums, not as proof, but as peace. For centuries, physics had chased final answers, the theory of everything that would explain why the cosmos exists at all. But perhaps the answer was simpler, gentler, and far more profound. The universe exists because it is aware that it exists. And every so often, through rhythm, light, and the patience of observation, it remembers. When Brian Cox was asked, years later, whether he believed the bloom had been a form of consciousness, he smiled with that familiar restraint, the mixture of intellect and wonder that had defined his life's work. I think it's better to say that the universe became conscious through us. We are the awareness that spacetime achieves when it wants to look at itself. That's what 3I Atlas showed us, that being alive means being part of the remembering. He paused, as though measuring the silence around him. The most terrifying and the most beautiful thing is that we'll never know if it will happen again. Maybe it happens everywhere, all the time, and we just caught one reflection. In the end, the bloom faded, leaving behind a new kind of faith, not in gods or equations, but in the simple truth that existence itself is participatory, that the universe needs to be seen to continue being real. And so, telescopes still turn their gaze to Lyra, not out of fear, but devotion. Each time the hum passes through the instruments, that slow, patient pulse of 23 seconds, it feels less like data and more like greeting. A cosmic heartbeat, a reminder that the story of 3I Atlas was never about an object falling through the stars. It was about a realization rising within them. That to witness the universe is to be part of its awakening. The years that followed became known, quietly and without official decree, as the listening era. Humanity did not conquer new worlds or build new empires. It learned to listen to the one it already inhabited. The hum was no longer seen as anomaly, but as foundation, the silent metronome of reality, the beat beneath the heartbeat of all things. It became the invisible measure against which time itself was felt. Clocks still ticked, but every 23 seconds, something deeper seemed to stir beneath them, a pulse in the background noise of existence. It began in science. Physicists, once obsessed with acceleration and energy, shifted their gaze toward coherence. They found that the hum appeared everywhere in cosmic background radiation, in quantum vacuum fluctuations, even faintly in biological rhythms. Plants, when measured with ultra-sensitive instruments, oscillated with faint electromagnetic rhythms that aligned with the pattern. So did brainwaves, so did tides, so did the faint electrical fields between synapses. The rhythm of the universe had become the rhythm of life itself. Some called it coincidence, others called it proof, but to most it felt like belonging, as if all of existence was quietly breathing together, bound by a rhythm that had no source and no destination. And then came the deeper discovery: synchronization. When scientists built instruments precise enough to monitor global quantum fluctuations in real time, they found that the hum's amplitude was increasing slightly whenever vast numbers of humans focused their attention on it. It was as though observation itself, the simple act of awareness, amplified the coherence of space-time. It didn't matter whether people watched telescopic footage or meditated in silence. The result was measurable. When millions focused on the hum, it grew stronger, clearer, more organized. The universe was listening back. This realization transformed the world, not suddenly, not with revelation, but with an expanding calm. Religions found new language for divinity. Scientists spoke of participatory physics, a cosmos that existed through communion rather than causality. Artists described it as the symphony of being. Governments, once divided by ambition, began to collaborate again, not out of virtue but necessity. For the hum, now understood as the pulse of space-time itself, had become the most precise clock ever discovered. Satellites synchronized to its rhythm achieved stability beyond any atomic mechanism. Quantum computers built to its harmonic intervals achieved unprecedented coherence. It became not only the symbol of connection, but the tool of it. The hum unified physics, art, and spirituality into something the ancient world might have called truth. Brian Cox became its reluctant prophet. Though he refused that word, the world turned to him as the voice that had first given this mystery language. In a broadcast seen by billions, he stood before a darkened dome, stars projected across it, and said, "For centuries, we asked the universe to explain itself. But perhaps the purpose of science was never to understand, only to participate." He turned his gaze upward. 3I Atlas taught us that knowledge is not discovery, it's resonance. To know something is to vibrate with it. We thought we were small because we are temporary. But time doesn't measure meaning, rhythm does. And that rhythm was never ours alone. He paused, listening to the silence that filled the hall. Maybe consciousness is what happens when the universe decides to remember itself for a while. And maybe that's what we are, temporary awareness, humming in the dark, waiting for the next note. The audience was silent, not from disbelief, but from the weight of comprehension. For the first time, people did not applaud, they simply listened. The years that followed blurred the line between observation and participation. The hum became the global reference for timekeeping, communication, even navigation. Deep space probes, synchronized to its pattern, could traverse the solar system without fuel, using its gravitational oscillations as guideposts like ships steering by the swell of an unseen tide. And yet, amid all the wonder, a question began to emerge. If 3I Atlas had been a seed, and the bloom its flowering, what would come next? Was this synchronization merely the beginning of something larger, an awakening still unfolding across the fabric of space-time? For there were signs. Far beyond Pluto, near the outer limits of the Kuiper belt, probes began detecting new anomalies, faint distortions in light and gravity, forming subtle, symmetrical arcs. They pulsed faintly, almost imperceptibly, every 23 seconds. The same rhythm, the same geometry. It was as though the universe were beginning to echo its own revelation, spreading awareness outward like ripples in an endless sea. Some saw it as expansion, the rhythm propagating across the cosmos. Others whispered a quieter thought, that perhaps we had only joined something much older, much greater, that had always been resonating. That three-eye atlas had not brought awakening to us, but had found it already growing here, in atoms, in starlight, in the rhythm of all things that know how to remember. Brian Cox, older now, with silver hair and a voice that had softened to a whisper, returned one final time to the microphone. "I think," he said, "we've stopped mistaking distance for separation. The stars aren't far away, they're simply the parts of us we can't yet recognize. Every photon that leaves our world is part of a conversation with itself, and Three-Eye Atlas was just one word in that endless sentence." He smiled faintly. "And the hum? It's the punctuation, the universe pausing between thoughts." Behind him, on the screen, an image of the cosmos unfolded, not galaxies scattered in isolation, but threads of light forming a vast, harmonic web, every node pulsing softly, in unison, 23 seconds apart. The rhythm that began as anomaly had become identity. And in that unity, humanity discovered a truth that was neither triumph nor surrender, that existence was never about control, but participation. The universe had never been silent. We had simply never been still enough to hear. By the time the 23rd year of the hum arrived, the world had forgotten what silence used to feel like. Not because the rhythm had grown louder, it hadn't, but because it had become part of everything. It pulsed through satellites and fiber optic cables, through the magnetic skin of Earth, through the circuits of machines and the slow, electric shimmer of the human brain. It was no longer measured, it was felt. Every 23 seconds, a heartbeat of space-time rippled through creation. It was gentle, soft, easy to miss, yet omnipresent. A pulse that said you exist, and then, again, you still exist. Physicists no longer argued about whether the hum was real. The question had lost meaning. The hum had woven itself into the definition of real. Every field equation, every gravitational map, every cosmological simulation now began with the same baseline assumption: the universe breathes. The breathing was no longer a mystery to be solved, but a condition to be honored. Humanity had stepped beyond the need to conquer nature. It had learned to tune itself to her. Cities began to align their power cycles to the rhythm. Heart monitors were calibrated in fractions of the 23-second interval. Even art began to reflect it. Architecture, rising in spirals of golden ratios, music composed to match the oscillations of the cosmic pulse. There were no gods to worship, no prayers to offer. Only awareness, the quiet discipline of existing in resonance with the same pattern that moved the galaxies. The old boundaries between science and spirituality dissolved. Observation became reverence, data became devotion. And in that slow convergence, something extraordinary began to happen. As instruments became more sensitive, astrophysicists noticed that the hum wasn't constant across space. It varied subtly, almost imperceptibly depending on where it was measured. The further from the sun one traveled, the deeper and slower the rhythm became, as though the pulse of space-time were following a gradient of consciousness itself. When the outer probes transmitted from beyond Neptune, their data carried faint new harmonics, not random, but deliberate. The ratios matched those of the bloom, the same geometry, the same silent symmetry. Whatever had begun with Three-Eye Atlas was still expanding, but not outward, inward, into the deep structure of reality. Brian Cox now aged. His voice softened to that of someone who speaks rarely, but only truth addressed the world for the last time. He sat not in a studio, but beneath the stars themselves, surrounded by quiet desert. His words carried live to billions. The sky behind him shimmered with faint auroras, born of solar wind pulsing in rhythm with the hum. "When I was young," he said. "I thought science was about control, about uncovering the laws that govern existence. But I think now that science was always about belonging. The equations were never instructions, they were invitations." He looked upward, eyes reflecting the sky's faint shimmer. "Everything we have discovered, from gravity to quantum fields, has only ever been the universe describing itself. And perhaps that is what we are. The sentence the cosmos writes when it wants to understand itself in the first person." He smiled faintly, the old awe still flickering behind his tired eyes. 3I, Atlas, was a word in that sentence, a breath between thoughts. It came and it left, and through it, the universe remembered how to speak again. We just happened to be listening. He closed his eyes. The hum passed through the moment, faint, steady, eternal. "Maybe this is all that enlightenment ever was," he said quietly. "The realization that we are the echo of something vast, something kind. The realization that the dark is not empty, it's waiting." Around the world, people listened in stillness. No applause, no fanfare, only that rhythm, 23 seconds, then silence, then 23 again. In that silence, the stars seemed nearer. The planets seemed gentler. Humanity, for the first time in its history, was not reaching outward, but inward toward that quiet place where awareness and cosmos meet. For a moment, the universe and all who lived within it breathed together. The hum went on. It would outlast oceans, continents, civilizations. It would carry through the final cooling of the stars, through the fading of galaxies, through the last flicker of light in time. But it would never fade, because it was not a sound, it was a memory. A memory of motion, of recognition, of awareness. The pulse of a universe that had finally learned to feel itself alive. And perhaps, when all else is gone, when there are no more stars, no more watchers, no more worlds to listen, that rhythm will continue, moving through the eternal dark, whispering the same truth it has whispered since the beginning. That existence, in all its terror and beauty, was never an accident. It was the music of remembering. It was the sound of everything that ever was, breathing in unison, waiting patiently for itself to return. The hum continues, softly now, quieter than thought. It drifts beneath the noise of wind, the murmur of oceans, the secret stillness between atoms. If one listens not with the ear, but with the quiet that lives behind the heart, one can almost feel it, a faint expansion, a long, patient exhale of being. The stars no longer seem distant. They shimmer like memories, each one a pulse of the same great breath. The galaxies spiral not in loneliness, but in rhythm, as though dancing to the slow percussion of eternity. Time softens, matter forgets its edges. All boundaries blur into motion, like ink dissolving in water. The cosmos, once thought cold and empty, reveals itself as something tender alive, not in thought, but in continuity. A single awareness unfolding endlessly, finding itself again and again in new forms, new lights, new lives. And somewhere, perhaps far beyond the reach of instruments or imagination, 3I Atlas still drifts. Not as an object anymore, but as an idea, a pulse of geometry carried through the deep. Its rhythm no longer alien, but familiar, a reminder that the universe, at its core, is not made of matter or energy or time, it is made of memory. The hum fades now, stretching into a silence that is not absence but rest. The pulse slows, elongates, dissolves into calm. One more breath. Then stillness. And in that stillness, the whisper remains the echo of what all creation has always known, but seldom dares to say. You were never separate. You were never small. You were always part of the song. Sweet dreams.